That one? Okay. I feel pretty confused and lost. I don't know where I am. What's going on? What's happening?
Externally, so now anytime I want to change the settings I can just change this. Hello and welcome to another how to code a game like Minecraft in Unity video. This is part 18, I think. Yes, part 18. And in this video, we are going to make a external loader for settings. There's 5 or 6 different things that I want to do in this series next. The problem I'm coming across is that basically I just can't decide which bit would be best to do first. All of these sort of cross over a little bit. So, for example, for having the external block data, it would be greatly beneficial if I had the complete block data hierarchy set up, all the information that we need for a block before trying to do an external data load, and we're not there yet. I'm just having to try and pick and choose which ones I want to do now and then have to revisit later when I've added another feature, and which ones we can just get on with. So while I wrestle with those demons, we're going to do an external settings file, which is nice and simple, and it's some of the technique we're going to use here will come in later for the external block data. So let's get started on this. And the first thing we're going to need to do is we're going to need to open our world file, and we're going to need to create a new...
Oh, we're already at it. Okay, opening C# project. Go to our world.
class, which is getting very crowded in here actually. We'll probably do a refactoring episode at some point. So this class is going to be serializable for now, which, if you don't remember, it needs to be serializable so that we can see it in the inspector here. And then we're just going to call it public class, nice and simple, settings. Now, it's not really important for the game as such, what we put in here right now. This is probably going to be a matter of preference, to be honest. I mean, there's going to be some stuff that you definitely want to have in here, but if you decide that you don't want the exact stuff that I put in here in your settings class, it's not going to break the game. As long as you have your settings in place, it should be fine. So the first setting that I want to bring across is actually one from voxel data, and that is view distance. So all these up here, chunk width, chunk height, world size is a bit different, but chunk height, chunk width, the size of the texture, all that kind of thing, that stuff is fixed. So that stuff does not want to change once the game is underway, because if we change the size of the chunk midway through the game, it's going to cause all kinds of hell when it generates chunks and all sorts. View distance we can change at any time, so that doesn't really need to be a public static read-only class. So we're going to get rid of that from here, and the reason we're deleting it now is so that all the errors will pop up, and then we can...
Wait, what did we this?
can quite easily find instances of it, but for now we're going to put in here public... Nope, it's not an int, not a float. Public int view distance. And then what we'll do, just to get rid of those errors for now, is we'll come up to the top, we'll go here and we'll create a new public settings, and we'll just call it settings. And then if we go find these instances, instead of voxel data.view distance in chunks, we're just going to say settings.view distance, and then we'll copy that and replace all these. Now if we go into our world...
Hold on. Calm down. I don't know how he like selects the whole thing. Is there some secret thing? No. That's like the best I can do. I wish the delete button was like on the left. To be honest, like going over here sucks. I wish the arrow keys and the delete and insert button was on the left, kind of. In a way, I also don't, but I also kind of do. Having to go over there is just terrible. I wouldn't mind having another delete button. Like having two.
In the inspector, we should find we have this settings drop down here, and in the view distance, we can change the view distance. We had it set at 5, so I'm going to bump it up to 9 just so we can see a difference in it working, and we'll run that, and hopefully it should all work. There we go, and it's taking longer to load this time, but it is loading much more world than it was loading before. And obviously, when the game's actually running properly, you wouldn't see this happening, because you'd be looking at a loading screen while the world is being generated. I'm going to bump that back down just because we're going to be loading the game and unloading it and everything, so we don't have to wait that long every time I load the game. But now that we've done that, the next thing we need to do is decide what we want in here. So
I don't want the camera here to be... Where are the thingies? Supposed to be thingies. Gizmos. There. It's supposed to be a 3D camera. And it's supposed to be like... this? And then we got the world there. Okay, so not like this. Like... why is it doing that? Just spin around, asshole! No, you're supposed to be the other way around! Why is this so hard? Right? Yeah, it's supposed to be like this. Why is that so hard to do? Why won't it let me do that? No? You fucking cunt. You piece of shit. What a dog shit thing. This is right? What's with the culling? Jesus Christ. You don't have to go so close for the trees to pop in. Wish I had a little more detail here. Like, I want to see the trees here. maybe it's just because they're so small it doesn't show. Like the transparency overtakes it or something. But at least it shows now, and we can see our... This is how I want it to be. I want to be able to play it and see as the world generates on the fly. See when the chunk crashes? Almost no sense to me. But regardless.
Oh, one of the first ones, and it's one that people have asked about in the comments quite a few times, is the mouse sensitivity. So we'll create a new float, and we can organize these later. For now, let's just put them in as they come to mind. And then to implement mouse sensitivity, we'll open a player script, and if we go find where we rotate things, so mouse horizontal, mouse vertical, we'll times that by world.settings.mouse sensitivity. Then we'll go back here, and just for ease sake, we'll put a range on that. So we don't want it to be 0 because that wouldn't move at all. So we'll start with 1F, and we will go up to 100F, which might be a bit excessive. We'll test it and see. There we go, we've got a mouse sensitivity slider. So 1 is basically what it was before. So let's just run that and see how much of a difference changing it makes. Oh yeah, that's very drastic. Okay, so maybe up to, I dread to think what 100 is going to be. Unusable is what 100 is going to be. So we'll change those values a bit. Let's go 0. We've got 0.1 to 10. I don't think anyone's going to need to go more than that. And obviously 0.1 also pretty much unusable. But you get the idea. So I think 2 will be a nice value for now. And obviously play with these values, get everything how you like it. So the next one we will add is enable threading. We'll start to break these into categories. So this one wants to be up here. And we're going to call this, what did we call it in the, up here? Performance. So yeah, view distance, enable threading, that all falls under performance. And then this one we'll just call controls, I guess. Now I'm not sure if these headers will actually show up, because I think you need to... Oh, they do, okay. I seem to remember there being a thing, maybe it was an older version of Unity, where if you didn't have a class in its own file, sometimes the headers didn't show up in the inspector. But maybe I'm remembering that right. Actually, it might have been scriptable objects. So now that we've got that, let's just go up here and we will delete that. And then once again, we can swap out.
He had up and he deleted oh, that was the threading thing. Yeah, whatever.
Delete that, and then once again we can swap out.
I didn't even put that in.
Threading references for settings.enable threading. And then we want that enabled. We'll have a new category which we'll call world gen. And then we'll put in here, we'll put our seed. So actually that wants to be public. Public seed, public int seed. And then we'll go up here and we'll delete seed from here. And then if we go down here, we can just stick settings in front of that. And that fixes that. That now becomes part of our external file. And again, you wouldn't really have that in your settings file. This is more for game settings. So this is just to get more values into the settings, because if we're going to save it to an external file, it seems a bit pointless just saving 3 values. So we've got our seed in there. and then we'll just put a random value in there. Now we can't put our biome in there because we can't save a biome. The way that we're going to save it, we can't save a biome file. We can do other stuff. It doesn't actually matter because that's not how the biomes are going to work when we get further into the world generation. So that would pretty much just ignore that biome file. And then we'll just stick a few other values that don't actually do anything right now, but you know, we can save them anyway. So header, we'll call this one game data. Yeah, we'll go with game data. And we will say public string version, and I think we will go with that. So if we just wait till version pops up, 0.0.01, I don't know. So we've set the settings in the inspector here. We're now going to save those settings to a file, and we're going to use a JSON file. So if you don't know what JSON is, it's basically a way of saving data in a very readable format, although the way Unity outputs it, there's no line break, so it becomes incredibly less readable. But it's a readable format, so it's clear text, and you can quite easily save fields. So we could have multiple instances of game settings, for example, and then each field within those game settings, and it saves them in parentheses and curly brackets, and then you can extract them back out of the file in much the same way. So we're gonna go back into our world, and we're going to need, if I can remember the name of it, system.io, I think it is. Well, there's no error, so that must be the right one. We'll go down to start, and before we get into anything else, we're going to say new string JSON export equals, and then we want JSON utility dot to JSON, and then we're going to pass it these settings. So
where the fuck is JSON? It has a thing. Doesn't it? Runtime resources. Maybe it is in IO. It goes to start. String JSON export equals JSON utility. Yeah, we got it. To JSON settings.
So basically, that is going to take our settings file, settings class, sorry, convert it to JSON formatting, and then stick it into this string. So if I then debug.log JSON export, now if we then run that and we look in console, you can see that we've got all the data that we just saved in that settings class has been saved into that string there. So what we can do then is we can save that string to a text file. And the way we'll do that is we will say file.write all text. Then we're going to pass in application.data path plus, we'll call it settings.cfg. I don't know. It doesn't really matter as long as the file format is correct. Unity doesn't care what you call it. And then we're saying JSON export because that's the JSON string.
All right. File.write all text. Application.data path. Settings.cfg. JSON export.
String that we're passing in, and this actually wants a slash there because the application path doesn't include a slash. So if we then try that, and this time we're going to be watching our asset window rather than our console, we should see a file pop up. Again, we don't.
Yeah, we do.
Oh, there it is. And as you can see, we have all our information there. And now what we can do with this is we can then load back out from the file that we've just saved to. And then the way we're going to do that is we will comment this out to start with. We don't need this, we don't need this. And then we start off with a string which we're going to call JSON import, and it's going to equal file.readAllText, read all text, and then we want this exact same path. And obviously if you ever change this settings location or the name of the settings file, it's going to cause problems in here. Pass in that exact same path. So that will load in the same way that we converted our player data to a string and then exported that string to a file. We're now bringing that same data file or that same data back in as a string. And then we're going to say settings equals JSON utility dot from JSON, and then we want to give it type settings, and then we say JSON import. Now if I run that now, we're not going to see a whole lot of, well, we're not going to see any difference unless something's wrong and there's an error. However, if we now change, if I open this up and I change, let's say view distance to 15, something big, and then save that and we press play, we're now getting a much bigger world. And if we look at our world script here, our settings now has 15 as the view distance because that has been loaded from the external file, which we edited externally. So now, anytime I want to change the settings, I can just change this. And obviously the plus side of that is if you ever for some reason accidentally wipe your inspector or anything like that, all of the information will be stored in your settings file, which right now, when we've only got this many settings and some of them aren't even necessary, is not a big deal. But as the game progresses, it will become more of a big deal to have your data stored external to the Unity editor, and especially when we really start getting into the block data types, because right now with whatever we've got in here, 12 different, or not even 12, 11 block data types, it's not, again, not that big a deal. But if you think about, there's something like, I'm sorry, I'm not sure exactly, 256 default vanilla Minecraft blocks. I might have just pulled that number out of thin air, but there's, you know, quite a few blocks, and if we had all the information for all of those blocks stored in the inspector here, and then we accidentally deleted that array for some reason, or renamed it in the script and forgot that that clears all of the array data here, that would be a nightmare. So that's all for now. Like, this is a bit of a this is a far shorter video than normal, especially for a Minecraft video. I did mention at the start I'm having a bit of an existential crisis as to which direction to go next. The lighting obviously is important, but the lighting is another one that is kind of, do I want to wrap that up in with some more shader work, because some of the shader is far from finished. It's just we had got it far enough done to be able to do the lighting, and I didn't want to spend episodes and episodes on the shader. Basically I don't want to spend too much time on any one aspect. If I can move on, I want to try and keep things moving around so that we're learning different things. So yeah, that's the struggle I'm going through at the minute, but I will figure it out eventually. If we have to bounce around a bit, we will bounce around a bit, but that's it for now, and I will figure out what I'm going to do for the next video before the next video. Thanks for watching. Bye bye.
It's good that the videos are short because I don't really want to do this but I've already dedicated myself to getting through these tutorials because I feel like it might be a good idea to see a different way of doing things. But otherwise, I think I can already do everything I need to do. Like cellular automata and stuff. But he also has a 7 days tutorial where he talks about marching cubes, for example. And I want to see how that works. Because I want to have... I don't want squared blocks. I want square blocks, but I don't want square blocks. I want them to be able to have a varying amount of mesh points, so that they can have different shapes, have slopes and stuff.
Real-time reflection probes can come off. Hello, and welcome to the latest video in the How to Code a Game Like Minecraft series. This one is going to be a bit of a short one, and it's just going to go over a few little...
Bit of a short one. It says build and run. We're just going to build and run it, I guess. But sure, let's watch it. However, it's 24 minutes. It's not short. It's just like the same length as his other videos. Let's check my humidity right now. 24%.
Fixes and optimizations. There's a few things that have been cropping up in, say, the comments in Discord, little bugs and just general issues with the build so far. If anything doesn't get covered in this video, it doesn't mean that I'm ignoring it or anything. It's just, for example, there is some player controller stuff that I'm not going to cover in this video because there is going to be another video on the player controller in the near future where we add things like field of view change when you sprint and a few other features to the character
Maybe
controller itself.
deceleration.
In that video, we will do a few improvements to the existing player controller. So for the first one, and I'm sorry, I'm just going to pull up Discord because I completely forget the username of the person who brought this to my attention. Bogdan55 brought this issue to my attention that I hadn't actually seen before, so I'll see if I can replicate it because it's a bit hit and miss. Okay, so the issue is if you place a block anywhere and then you move, sometimes the chunk disappears. And in this case, we had 2 chunks disappear because I placed a block across a chunk.
They're dealing with the chunk issue.
And then if you move again, it's basically when you're crossing the boundaries of chunks and it's running the check view distance function. Every now and again, it's not 100% of the time, but it's replicatable. The chunks will just pop out of existence. So if you watch on if I just keep walking and pressing the place block button, you'll see at some point a chunk will disappear. This is what I meant about it not being replicatable all the time, but you saw it happen. So basically that is being caused, after a bit of debugging I figured out, by the fact that once again our threading is causing issues. Both our second thread and our first thread are accessing the active chunks list, wherever it is, this list here. It's been added to in both our update chunks function, which is called in the threaded update if you have threading enabled, but it's also called in our check view distance function, which is in the main thread, which is what's causing the issue. Is that every now and again things are getting a bit messed up. The quickest way I found to fix that for the time being is if we just stick a little check in here to say if active chunks does not contain the chunk that we are currently planning to add, then add it. So
if not active chunks that contains chunks to update index.core.
So we're only adding it if it's not already in the list. If we try that now, one thing I'm just going to quickly do before I run this again is I'm just going to change the size of the world, or the draw distance, sorry, because I'm going to be loading and unloading the game a few times in this tutorial, and it's painfully slow to wait for the world to generate. I mean, you know how long proper Minecraft takes to load up a new world. We're essentially a much smaller world, but we're essentially doing this every time I press play. So I'm just gonna shrink the world a little bit. So now if I do it, you can see the chunk doesn't pop out of existence. So I'm sorry about that, Bogdan, and anyone else who experienced that issue. Well, I imagine all of you experienced that issue. I don't think it's something that's system dependent. Maybe somebody with a faster or slower machine might have experienced it differently, but Bogdan was the first one to bring it to my attention, so thank you and sorry. So probably the next most commented problem I get is about the player controller. Basically, the bounds are not quite to everyone's liking, and you can sort of clip the camera through the planes there, which obviously isn't ideal. The reason I haven't addressed this before, well, I mean, I've addressed
no
it
one's commenting on the fact that he's using get access, so you're like drifting around like a fucking hover tank.
Easily accessible, which I will do now. There is another problem that I'm not going to address in this video, which is how you can basically ground the player at the side, like against a wall. So essentially, I can jump. If I just try and make a bigger wall here, it's a bit easier to demonstrate. There we go. Okay, so if I jump against that wall, I'm now sort of floating because the game thinks I'm grounded because I've managed to hit this wall. So basically, it's checking on one side of the player because we're doing these 4 checks on each corner of the player's position, and it's finding that the player is in a solid block on one side. So then it's registering as grounded. Obviously, that's not the case because we're not, you know, we're in a wall. So we will fix that when we do the next player controller video. I'm not going to address that in this one. I just wanted to let you know that I'm aware of it. But as for the clipping and the bounds and everything like that, if we just head over to our player script, and actually I made these public, so we don't want to go in the player script, we want to go over here. So we'll make the player width 0.25, and then if we open up our player a bit, go to our camera, we're going to move the camera back to -0.15 on the z-axis. So you're never looking behind the player. Whichever direction you're looking, that is the direction the player is facing. So it doesn't matter if the camera is a little bit back from the front of the player, because it's not like you're going to turn around and suddenly be sticking out the back of the player. And then the final thing we're going to do to the camera is we're going to change the near clipping plane, so that's down here, to 0.1. So now let's give that a try. So now if I walk up to a block, you can see we're not clipping through it anymore. And just in case anyone here isn't aware, the clipping planes are basically the start and end of where the camera can see. So the far clipping plane, anything beyond that doesn't get rendered. Like the camera, it's kind of like having a view distance. Well, it is a view distance, but it's like a hard view distance. So no matter what's going on in the world, nothing will get rendered past that far clipping plane, which is a sort of a performance upgrade. If you know how far your view distance is in the world, in your Minecraft game, then there's absolutely no point in having a clipping plane further than that view distance. So you could bring the view distance, the clipping plane, backwards and forwards depending on the size of your world. And then obviously the near clipping plane is how close to the actual camera you can see. So before it was 0.3, so it was just a little bit further forward, so anything behind that doesn't get rendered. So we've just moved it a little bit closer to the camera. There's less chance of anything getting behind it and then, you know, not rendering anymore. Now, to the bulk of what this episode is going to be about, the main thing that people have found issue with is performance. So we're going to do a few performance upgrades.
Oh
now,
no.
I won't drag you through the process of how I came to choose the performance upgrades that I'm about to show you. Needless to say, it involved a lot of going into Analysis and Profiler and seeing what was eating things up. Maybe we could do an episode on Profiler at another time. I imagine, most of you seem to know what you're doing, most of the people who watch these videos. So I would guess that most of you have had experience with the Profiler, but if that's something you'd like to see a video on, then just let me know.
Don't
First thing we're
expect
going to do
that.
is we're going to look at our camera. We have on here a flare layer, which was just there from the default camera that's set up when we started the project. We don't need that. We don't technically need the audio listener, but I'll leave that there for now because we...
What did we have? That's just my third person camera, right? Did he do?
That's set up when we started
Layer
the project.
layer? I've never seen that on a camera.
We don't need that. We don't technically need the audio listener, but I'll leave that there for now because we will at some point. These are minor performance tweaks, by the way. None of this is going to make a huge difference. These are all just little things that add up. Now, the second thing is we're going to do this for now, but obviously we're not going to keep these highlight and place highlight blocks indefinitely. At some point we are going to be changing them, but for the time being, both these cubes have a box collider on, which is obviously stupid. We do not need them. So remove those because physics is probably the most CPU consuming thing, or GPU, I'm not sure which one it is. It's one of the most system intensive things that you can do after graphics. Maybe it might even be worse than graphics, it depends on the physics. But the problem is, like in testing, I found that those two little blocks were showing a significant amount of system resource usage. And when I say significant, I mean relative to everything else. Obviously, just having two blocks floating around in space isn't going to cause the system to lock up, but relative to the total usage of this build, those two blocks were showing up quite a high amount. So we're just going to remove those two box colliders. The next thing we want to do is we want to go into our world script, and just to save a little bit of time, we're going to cut this out, and we're going to...
Right. I guess let's see. In world. Update. Shader stuff.
To cut this out, and we're going to put it in a function, because right now we're setting that every time and we don't need to set it all the time, every frame. So we'll make it public in case we want to access it from anywhere else. Global light value. And we'll just paste that in there, and for now we're only going to call it once in our start. Sorry, that wants to be a void. So as this is now, if you change the global light value during the game, it won't do anything. Like if you change it in the inspector, if you change it here, it won't do anything. However, you wouldn't be changing it there in a proper game anyway. So what you could do is, if you want, for editor purposes, you could add an editor script to say, if this changes, run this function. But chances are you're going to be editing it in the script, in the code. You're going to be moving the time along as, you know, as time goes on. So you would just simply, you know, call that function in here at the appropriate times. So we're not going to put anything like that in yet because we haven't got a day-night cycle. For those of you who have got a day-night cycle, I know some of you have been experimenting with it. It's not going to be difficult for you to figure out how to do that, and it's probably not going to be much of a performance boost, but it's just an unnecessary call. Even if you have got a day-night cycle, you don't really need to call this every single frame. And also, if you have got a day-night cycle, you want to be caching your camera. Do not call camera.main every frame. That's incredibly inefficient. I'm pretty sure I said at the time that that's not the way we should do it. It was just a temporary thing. I'm not going to change it now because, like I say, this is only getting, in my build, this is only getting called once in the start menu, so it doesn't really matter. So now we want to go down to our check view distance for another little improvement. Here we are. And what we're going to do here is we are going to replace, and again, this is a very minor improvement, but every little helps. We're going to replace, see all these here where we say new chunk card, new chunk card, new chunk card. Every time we do that, it's a little bit of system usage that we don't need to be using. So we're going to make a new chunk card, which we'll just call this chunk card, and it's going to equal, and we'll just grab that. And then we will use that instead of making a new chunk card every time. All of them. There we go. Right, so that's just a little, again, this is an every little helps kind of thing. So now we want to go into our chunk. And what we're going to do in our chunk is we go down to...
Yep, let me do that. Yeah. We go into our chunk,
where we create the mesh. In our create mesh, we have this function being called. Now the normal, if you remember from I think the first episode, the normal is like sort of the direction the vertex is pointing. So in this case, the top face of a voxel, all four vertices that are on, or vertices that are on that face, are all pointing straight upwards. And this goes through and basically does a best guess for which way a particular normal should be pointing. It works it out pretty accurately. Well, it works it out exactly on this particular mesh because all of the vertices in a given face are all pointing in the same direction. So it's fairly easy for it to work out what to do. However, this is an unnecessary calculation. We know which way the vertices are going to point because it's a cube. So we're going to create a new list. We'll go back up to the top. Just the same as all the other ones. Vector 3. Normals equals new list. Vector 3. And then we want to make sure we add that to our various functions. So if we go down to clear mesh data, we need to put it in here, normals.clear, and where is the create mesh? There it is. So instead of this, I'm going to say mesh dot
instead of this, mesh dot normals
equals normals dot to array. And to actually set those is surprisingly easy. Basically, we're adding, for each vertices, we're adding a normal value, and the normal for any given, so bearing in mind that this loop is each one face. Every time we go through all this code, that's one face. So we know that all the normals on whatever face we're adding are all facing the same way. For now, obviously, it's going to get a bit different when we add things like stairs and other shape blocks, but for now it's the same. So we can just say int I equals 0, I is less than 3, because this 4 faces 0 to 3, I plus plus. We don't need parentheses for this, it's only one line. And then we're just going to say normals dot add, and then because our face checks that we're using up here basically gives us the direction that we need to point anyway, we can just steal that. So voxel data dot face checks P, and that's going to add the normal for us, and that's all we need to do to calculate our own normals and scrap that entire function there. Now the other thing that we want to do here, and I did warn you guys that this would be coming back, having a transparent rendering material is more system intensive than having an opaque material, and right now as far as the game is concerned we have a transparent material or a cutout material or whatever you want to call it on everything, and obviously most of the stuff we're going to be looking at is going to be solid. Most of it's going to be grass and stone and dirt and things like that. So what we're going to do is we're going to bring back our second submesh. We don't want to use that as transparent. We're just going to steal this.
Hold on. Calm down. Son of a bitch. Doing that.
Because we renamed that. So we're saying if world isn't transparent, add it to the triangles. If it is transparent, add it to the transparent triangles. Obviously that means that we need to bring back all of this.
That.
And then if we go to the top, do we? Oh, we didn't comment that out. But we do need to change this back. And then that's going to equal materials.
Oh dear.
That needs to equal material. So I think that's everything in the code. But then what we need is we need our second material. So we'll go to here and we will create a new one. We're going to call this one transparent blocks, and we're just going to get rid of voxel and transparent blocks and this random skin one that was from a video that didn't get done because we don't need them. For now, transparent blocks is just going to stay as it is.
Transparent block. Well, it is obvious to most hard exercise will make you die when sick. I feel like I need it to shake out of the thing. Okay. Yeah, that's why I said like getting up is good. Maybe not necessarily going out and shoveling the entire driveway is good, but especially when you're old, like we are, and you're even older than me because you're super old. Just lying around really fucks with you. It really fucks you up a lot. It just makes you sicker. It's better to get up and like sit in the couch or something instead and watch some TV than just lie in bed. Because otherwise, when it's night, you won't be able to sleep either. So what did he do? Transparent blocks is also the Minecraft blocks.
And we'll drag that in, where is it? There, drag that in there. So this should work exactly the same way for now. Okay, the shaders work in the same way, but we have an error on our normals list. What's going on there? Oh, right, yeah, sorry. It's less.
Huh?
Than 4, not equal. It's I0 to less than 4, which is 3. So yeah, sorry, that should be a 4, not a 3. I'll just quickly make sure that error's gone. Right, much better. Right, so now we need our transparent material. So we'll go back into our scripts and we're going to duplicate the standard block shader.
Standard block shader. That's my block shader right there.
And this one we're going to call transparent block shader. And we'll open that up, and then obviously we want to change the name here, transparent blocks. And then we're going to delete all of this. No, sorry. This one we're going to leave as it is. It's the other one that we need to edit. We're going to delete all of this, change that.
Yes.
That to opaque, and then down here we want to get rid of this. So now if we go back to here and we look at our materials, you can see this is no longer transparent. And this one, if we switch it to our Minecraft,
You do it like that. You go into materials, click blocks, and then you can look at it here. Is it flat? Why are you flat?
transparent blocks, this one is transparent. So now we're only using transparent on blocks that need it, and that is
Huh? I mean, it's still transparent. The fuck is he talking about? They look exactly the same. Whatever.
is just less intensive on the system. And if we just run that just to make sure it all works, and there we go. We have our transparent leaves and our regular ground.
Oh, it
Forgot how to speak for a second there. So the
used to work.
last performance-y type thing that we're going to go over, I just want to check this because I can't remember if I did this on video or not. If you go to your lighting settings and just make sure that nothing's turned on, because we're not using any of the glow.
Yeah, we did that. We go to window, rendering, lighting. Light probe visualization, display weights, blah blah blah. Nah.
Global illumination stuff. We're doing our own lighting in the shader, basically. So just go in there, make sure none of that is turned on, and also go into project settings and
Okay, hold on. Project settings.
just go through this. You really don't want pretty much anything turned on, really. Soft particles can come
Quality.
off. Real-time reflection probes. Real-time reflection probes can come off. Billboard face camera position. I think that's pretty much it for stuff that we can turn on. Or disable shadows. I don't think that should, low resolution shadows should matter as soon as we've disabled them, but you get the idea. This VSync count we're going to come back to, because I need to have a quick word about VSync count. So now some of you are going to try this and you're still going to think the game is running a bit laggy. So I just want to show one thing, because there is a reason for that, and that's the editor. Basically, if you build out the game, you will find it runs so much faster than it does in the editor. So
That it's, you don't even need to do that. All you need to do is do this. Now it runs twice as fast, because if you have the game and the scene at the same visible at the same time, it the frame rate gets helped. Something keeps throwing an error. When I'm walking, the game ran at 60 FPS.
We're just going to quickly build the game.
I'm done doing that kind of stuff. Like, I used to do those kind of things. When I was still heavily into the like game dev community, I used to make like review videos or even review playthroughs for people's games and like talk about issues as they cropped up. But nobody cares enough. Like even if I did it after asking if they wanted it, it usually didn't end up with like solving anything or changing anything, or with them like even really being grateful. Even though it is like super useful, because you can see how people like having a video playthrough, you can see issues. It's so much better than having like just a bug report, because you can see issues that they don't realize are issues. There were so many things. Like I skipped an entire chapter in Arrowlight Core because he forgot to put an event in like one place that was supposed to block you. So I just like walked past an entire city and I was like, all right, let's go to the next chapter. I just thought it was just like a random city, like whatever.
And to do that, we need to make a few little modifications to, well, we don't need to make a few modifications, but we are going to. So the first one is,
What is he doing inside player?
if you go into our player, we go down to where we handle our inputs, which I've completely lost. Cleaner code, guys. Cleaner code. We'll go down to get player inputs, and I'll just stick it at the top here. Say if input.get_key down keycode.escape application.quit. Now that won't do anything in the editor itself, but when you actually build it and run the game, this obviously gives you a way of closing the game without having to Alt F4 or anything like that. The next one, we go to the top here, and no, not the top here, sorry. We want to go here, and we want to find our
world
in-UI function, bool thing, there it is. And we just want to say cursor.visible equals, what's this? This is in UI, so in that case it wants to be true, and then obviously the opposite down here, false, and then we're going to change here, we're just going to set in UI rather than
player. I've already fixed these things for him, to be honest.
set in the lock state in the player itself. So world.inUI equals false. Because what we were doing before, it doesn't matter in the editor because the editor works slightly differently to when it's a build, but basically the way we had it before, the cursor would have been visible in the actual build. Well, the cursor was visible in the build, I found that out. But there's no point in setting the cursor bool separately here. So all we're doing is we're making it so that this handles everything that we want to do with the cursor, and then we just set this bool. So we save everything, and we're going to go to File, Build Settings, drag that over here. So I imagine most of you have built games before. We want to make sure we add our open scene. There's the only scene we've got, so we don't need to worry about the order. If you click on player settings, you can go through all
Oh, what was he talking about?
the order. If you click on player settings, you can go through all this if you want. I'm not going to mess with anything right now. I'll tell you what, I'll put my name in there. Sure you get your version in there. If you want to give it an icon and all that kind of thing, a default cursor, all of that can be done in here, but that's pretty much it. And obviously all the settings that you get in your project settings are here, so you can mess with the quality, but we've already gone over that. So once you've done all that, click build, and I'm just going to create a folder in this project folder called build, and that's the folder we're going to use. And then we sit back and wait for a little bit. This isn't always the fastest process. And there you go, it has spat out a build for us. Now, there is one thing to note, and we're going to fix this in code at some point, but that is that our... where are we now? I'll just close that. Our settings file here. So I'm just going to open Show in Explorer. This settings file that we need, because we haven't got any other way of loading settings at the minute, does not get carried over. Now, we can put into our code a check to make sure that the settings file is there, and if the settings file is not there, to create a settings file, and we're going to do that eventually when we start really getting into the loading and saving and things like that. But for right now, all I'm going to do is load up the folder, and if you go into, if I can just remember whereabouts it puts it. Oh, that's it. Yeah, sorry. So it's the name of the game _ data. That is essentially your assets folder, or your application path as the...
But it sent me a pack of an Imperial Fists box. A pick of an Imperial Fists box you got for Xmas. Yeah. This is a strike force, not a whole army. Yeah. $210. Yeah. Why do you think Gibbs is planning on basically releasing our 2 first armies for free? He wants to destroy Games Workshop. Unity data? There. Yeah, it's Games Workshop. That's what he's picking. This game is just fine on its own. We're not trying to kill anyone with this. We're just trying to make a game. Would be easier to kill Catalyst. That's your job. Yeah, that works. I have built projects before.
It. So I'm just going to copy it there. And if you rebuild, if you're doing it this way for now,
there are still years left in you. You still have time to kill Catalyst. You just need to finish your game in 1 month in January.
And you rebuild your build, that settings file will get deleted every time. So you're going to need to copy it over every time you build it.
I've been to a little bit thinking about like how you implement a hex grid logically in the data, and I think it's literally just a 2D grid. Like you just do it like XY and that's it. Really, and you need to add like a little. You probably already figured this out. I don't know, but all I think you need to add is like, does going up in Y put you at +1 or -1? And that just depends on like if you're odd or even, I think. More or less. Yeah, because really all you need is basically like a way to store the data, and that's like that's about it. And I think it's actually pretty simple.
So if we just run it now, you can see, for one thing, the chunks are popping into existence a lot quicker. And if we go for a bit of a wander, there's no stutter or lag when we're walking around.
Oh, it's Red Blob. Yeah, I actually talked to Red Blob the other day. He helped me find some stuff. Yeah, his website is amazing, to be honest. There's so much interactive stuff, and he has a lot of visual representations of everything, and you can interact with it. You can see like instantly how everything works.
Now, I can show you the frame rate, but it's going to be locked at around 50, 60 frames per second and everything because of VSync. So this is why I wanted to have a word about VSync. Now, VSync, broadly speaking, sort of locks your game to the frame rate of your monitor, kind of. So it's like there's no point in using up system resources to show 300 frames per second when your monitor only refreshes at 60 frames per second. So it's kind of, you know, saving your system from excess, I guess you could call it. So if I just press escape now, you'll see the game closes itself. Now, what I wanted to talk to you about with the VSync thing, if I go into, because I might need some help here if anyone out there is smarter than me or just happens to know the fix to this. If I turn VSync off and then I rebuild our game, use the same folder, and this will be a lot quicker this time because it's already built it once. And before I click play, I need to remember to copy over the settings folder, settings file even.
Just buy one of those old ones with 3 mouse buttons.
Words are easy. It's not going to look any faster because it's only the frame rate we're talking about. Things load into existence at the same time. But if I press F3 here, you can see, and I move into the light a bit, you can see that it's running at between, well, 500 and 3000 frames per second, which is a marked improvement over 50 frames per second. However, the mouse does this. Now, I did a lot of Googling trying to fix this, because obviously I wanted to show you it running at a decent frame rate rather than just 50 frames per second. And I can't find anything that helps solve this problem. There seems to be a lot of problems where enabling VSync causes the mouse to go funny, and that's usually people using time.delta time in their mouse code, which I'm not doing. But I can't find anything that's the other way around, where disabling VSync causes the mouse to do this. Now, it doesn't do it in the editor, it only does it in the build. So I can't figure this one out. If any of you know, please leave a comment or send me a message on Discord or whatever. Just be aware that I have tried a lot of very obvious things. But yeah, so as you can see though, the frame rate is far better when you build it. So that is something to consider when you're looking at the performance thing. The Unity editor itself has a lot of overhead. So that is going to be it for this video. I think the next video we're probably going to finish off all the lighting stuff, get rid of these silly black shadows, and add smooth lighting. And then, I don't know, after that, I'm open to suggestions. I know a lot of people want to see more detailed terrain management. People want non-block shaped blocks and items, mobs, things like that. So, yeah, leave comments below. Let me know what you think. Let me know what you want to see next. Let me know if you know how to fix this blooming VSync thing.
My mouse works fine. So it's...
Real-time reflection.
I'm going to say that it's most likely because he is doing the mouse movement and everything inside fixed update. I have fixed update here, so if I move this there, and we try building it again. Paste the thing, you son of a bitch! Why do you clear the copy just because I pasted it? Screw you. Yeah, yep, that's why. It's because you had it in fixed update. Fixed update is for physics. And I don't really know exactly why it would do this, to be perfectly honest, but that is why. And that's like, he put a lot of things in fixed update, and none of this is physics, really. Like maybe if you keep the movement in there, but like pressing buttons, moving the camera, it shouldn't really be there. We're done. First build and run. Next video is basic biomes.
Hello, and welcome to the latest How to Code a Game Like Minecraft in Unity video. I apologise up front. This video was supposed to be on how to do the cross-chunk lighting and the smooth lighting and all that. A few of you voted on it in a poll that I put up on the YouTube community thing. The people in Discord know what's been going on, but basically the universe has decided that it doesn't want me to make this video just yet, and I do need to upload another video because, let's face it, I can't go weeks and weeks without uploading a video. So
Humidity 25%.
We're going to cover basic biomes, and then after that, the next Minecraft video will be finishing. It's
gone up 3%.
Apologies for that. Let's go with this one. So just quickly, before we get started, apologize for not doing this in the last video, but I really should have put a bool on the animated chunk loading thing that we did in the bonus video, so that you could easily turn that on and off. So if you didn't follow that video, you can ignore the next 30 seconds or so. But we're just quickly going to script, going to world, and we want to slide down to our settings. And we will put this in, I guess performance will be fine. We would just say public bool.
I spent all of Christmas night not being able to sleep because I was thinking about mapping a sphere grid to a sphere, or a cube or a square grid to a sphere. I have my humidifier totally shut down. It's still 30% and my windows are still icing at the bottom. This one, I actually noticed that it was an issue. It can, if you want it to be like at 35%, you're gonna have to manually check it because it only goes to 40% minimum. You can't do that? Yeah, exactly. You can't do that. It's impossible. But I spent the entire night doing it anyway. Because there, I think I showed you, but you've got, you can do this, right? You can have a pentagon. And then you can have hexagons here. I should just show the actual thing. But you can have hexagons like this here. And then you can have hexagons on each side like this. Kind of. That, and like that, and like that. And that way you can build a hexagon sphere using hexes and pentagons as vertices on this sphere. Yeah, it looks like this. You got pentagons here, and then in between you have hexagons, and you have a little hexagon world here. And it's like almost possible, because if you have a hexagon, you can kind of divide it into squares. Making a proper hexagon is fucking impossible. Let's see. Big does it need to be rotated like that? Damn it. Come on, stop being a dick. Neighbor's kid is having an absolute spurg out. Okay, cool. Yeah, that's great. Yeah, I love it. 18. There. This is topology, which is like 2 math years past where I almost failed. And that was with the help of a buddy who became a professor in topology. He has papers published. Yeah, but that's a lot different from just using topology based on a Google search. Like, that's the thing. Whenever people think that programming stuff is hard, or programming like physics or whatever is hard, it's because it's kind of hard to like do it from scratch. But when you're actually programming things for a game, all you're doing is you're like Googling a little formula and then you copy paste it. But the same thing is true for this kind of. But am I retarded? This is a fucking octagon. I made an octagon. God damn it, what does that hexagon look like? A hexagon looks like this. Man, I can't be arsed. Do this. You pull it up like this. So if you have this, you can actually split it like this into triangles, like that, and then right now you have a square here. This is a square, or at least a rectangle, which you could split into 2, and then you have a. And now you have some triangles here, right? But what you can do with that is you also have some guys over here, right? So that's now part of this too. So now you can have squares there as well. You can, yeah, I think you can kind of do something like this. And you can kind of generate a square grid based on hexes. And this is why my brain was like just going through this. And I'm not sure if it works. It might work. I'm not entirely convinced. But once you implement the pentagons here, it's fucked. Like you can't do it. The only way I was thinking was that I could have like these lines coming with my like kind of squares coming in here, and then I would like eliminate the middle of this and like put something special there that where you can't like build or anything like that. But the true solution to this is actually a lot easier. What you do is you make this, Congratulations. You now have a sphere. This is a sphere. Yeah. There. That's a sphere. And now you have a sphere with cube or with square grids all over the entire world. And the reason this works is because what you do is you have 6 XY grids of thingies, and then you flatten the edges when you render it, and you turn it into a square, or into a circle, or into a sphere. So then you have a cube that's a little bit deformed into a sphere, and the system works. The only issues you have is here on the edges here. It'll probably get a little bit weird to render it properly, because the 3 cubes need to be rotated like perfectly so they align to each other at that point. But I don't think it's really an issue. What you do is you kind of treat wherever the player and the camera is as the center here. Because otherwise, normally, it's the same as when you make just take a sphere and just put squares on it. They have to be deformed to fit. And when you do that, you know, a building would be bigger at the equator than at the south or north pole. Which makes no sense. But you just render it like you're at the equator, no matter where you are. So it doesn't matter how big it would be like deformed as a whole. Unless you like zoom everything out. But then you won't render those kind of structures anyway. You'd make like a screenshot of it and just put it on a sphere or something, more or less. So the true solution to gridding to mapping a square grid to a circle is to just make the circle a fucking cube. That's how you do it. And then it's like I said, it's just 6 arrays, and then if you walk off one array, that means that you're just walking into another array, and that's the end of the story.
Enable animated chunks, and then if go into our chunk file, and then in the bit where we add the component, we'll
over there
a if statement. So if world dot
it doesn't look that
settings
bad.
Dot enable animated chunks, and then finally we'll just go to our settings file, and we should be able to just put at the end here a comma, enable animated chunks, and we will set that to false for now because we don't need it while we're doing all this testing. Now if we go into world and we look at our settings, we should have enable animated chunks. I'm going to set that to true, and then you see it's set to false as soon as the game runs because it's pulled that information from our settings file. So that's that done. Now let's get into the biomes. So the first thing we're going to need to do is we're going to need to create some biomes. Right now we just have the one, which is we just called default.
New computer proof blows up centuries old fluid equation. What does that mean? For centuries, mathematicians have sought to understand and model the motion of fluids. The equations that describe how ripples crease the surface of a pond have also helped researchers to predict the weather, design better airplanes, and characterize how blood flows through the circulatory system. These equations are deceptively simple when written in the right mathematical language. However, their solutions are so complex that making sense of even basic questions about them can be prohibitively difficult. Perhaps the oldest and most prominent of these equations, formulated by Leonhard Euler more than 250 years ago, describe the flow of an ideal incompressible fluid. A fluid with no viscosity or internal friction and that cannot be forced into a smaller volume. Almost all nonlinear fluid equations are kind of derived from the Euler equations, said Tarek blah 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 blah. They're the first ones, you could say. Citing the beast. In principle, if you know the location and velocity of each particle in a fluid, the Euler equations should be able to predict how the fluid will evolve for all time. But mathematicians want to know if that's actually the case. Blah 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 blah. In my mind, I was actually kind of imagining fluid velocity being more like fluid rotation in a sense, rather than anything else, because it's like rotating around the pressure. I wonder. Mathematicians want to know when or if Euler's equations, which describe the flow of ideal fluids, will ever fail. In 2022, Thomas Ho and Jiaji Chen, based Chinese guys, proved that they blow up in a specific setting. Inside a cylindrical container, the top and bottom halves of a fluid rotate in opposite directions. These initial conditions lead to the formation of more complicated currents that cycle up and down. Websites that don't let you paste passwords are the most gigantic idiots. Password manager dudes lose once again. One password havers. Posting their W's. Not enough pictures. Well, whatever.
And it gives us like grassy land with trees. So we're going to need to make some changes in order to make some biomes. But the first thing we want to do is we need to slightly modify the way we do structures, which is at the minute is just doing trees. So let's go find our structures script, and we're going to create a new
Oh yeah, I still use my password that I know is like on a bunch of different lists. Like whatever, it's fine. At least for some things. It's the vsync there.
new public static queue, and it's gonna be vox.
All right, so what are we doing? Structure. Rockstar socials.
Mod, same as the other one, and we're just going to call this generate major flora. because we're just going to use it for things like trees and, in a minute, cacti.
But to be honest, I've only had an account hacked once in my entire life, and that was my Steam account. And that was like my first password, because it was on a list. I don't know anything else that's ever been hacked. Oh.
So this wants to take an index. I'll show you what the index is for shortly, and then the rest of it we'll just copy from here because it's basically the same thing. And then it's going to be a switch, which will take in that index value.
Yeah. They changed the account to Russia.
And then depending on the index value, it's going to call
those Russians.
Well, I say one of these. Right now, we only have the one, but there will be more than that. And that's how we're going to call structures in the future. And then if somehow we end up passing in a value that is not part of this, we don't have a thing for it, an index or a function ready for it, then we're just going to return an empty queue. That way there's no errors, and it's going to try and add an empty queue to the queue, which doesn't add anything, so it can just carry on going as normal. So now I want to go over to our biome attributes, and we're going to change this to major flora.
I wonder if those are worth hacking because people have piles of those shark cards or something. I don't know. Now we want to access biome attributes.
On the biome, it may not represent trees. And then we will also change all references to trees, just, you know, so things make a bit more sense in the code. Max height and min height, we'll just get rid of the tree part for now. And then if we go into our world script, we should have a bunch of errors.
No, we shouldn't have a bunch of errors. Just use rename, you son of a bitch.
Somewhere. There they are. So just fix these. And now we're not just calling for trees regardless of what it is that we actually want. And now the other thing we're going to do is we're going to have a bool in here. Public bool place major flora, which we will set to true by default. And as you may have guessed, this is going to give you the option to not have it place anything like this in a particular biome. And I don't know if I'm using the word flora correctly. I'm not a scientist, but hopefully it makes enough sense. So what we're going to say is here, where we check if the Y position is at the correct height to be placing flora, we're just going to say and biome dot place major flora.
There.
So now we're only going to be placing it if that is set to true in the biome itself. So the next thing is, right now we are placing grass and dirt blocks regardless of what the biome is, and obviously we want to be able to change that depending on the biome. So we're going to put two values in here. They're not floats, sorry, they are bytes, and they're also public. And we'll call the other one public byte subsurface block. Now remember, the way I'm doing things here isn't meant to show you the 100% everything, every tiny little detail on how to make Minecraft. I'm just trying to show you.
Oh, Formal Goose Foundation, how's it going? What am I building? Nothing right now, really. I'm planning on starting a voxel project after New Year's or so. I'm just following through this guy's Minecraft tutorial just in case, just to get like some basic sense of really how things work, or at least some other way of doing it. Minecraft clone? No, not really. But I do want the voxel placement and stuff. And I want to be able to build houses, and I want to be able to dig in the ground. But beyond that, I don't really have that solid plans. I just want to make a survival game, really. And not survival in the sense like that Minecraft is a survival game, because it really isn't.
You how to get started on it. So this is only covering the block that is on the very top of the terrain, and then the blocks that are just underneath it. Right now it's like one grass block, I think, and then three dirt
I want
blocks
sailing,
underneath.
like something
That's these
closer
two
to
blocks.
Valheim.
Surface is grass, subsurface is dirt. We're going to leave stone as it is. If you wanted to change things about a bit and have more layers, I think I've shown you enough to be able to figure that out by yourself. I have faith in anyone watching this video that they'll be able to figure that out. So if we go back into our world and our getVoxel function, somewhere here, right, so this is our grass block.
Okay, where the hell are you now? Basic terrain path.
Change this to biome.surface block. And then we want to change this one to biome.subsurface block. Then if we go back into Unity and we find our biome, we just want to set those values to make sure we actually get the blocks. Otherwise there'll all be air. So
go back to our biome. All right, we have a biome thing there. Man, how did that work? Where the hell is it? Is it in here? Tree textures? Materials, data, biomes, there.
So surface block was 3, I believe, and subsurface block was 5.
Okay, so he has like a biome file here where you can specify a biome, right?
We'll just quickly
I kind of remember now.
Hopefully it still works. So there we go, we have our surface blocks. And if I dig down here, it's all dirt. And then we can just test that by changing that to, I don't know what these blocks are, but we'll just put 6 and 9. So 6 is wood blocks.
All right, let's test that too. It works. I've got my snowy grass tiles. 6 and 9. Now it's a bunch of wood. All right, sure, whatever.
And then underneath we have cobblestone. So that's how that works. We'll just change those back for now. Now back into our world, we want to slide up to the top here, and where we have this public biome attributes, we want to change that to an array.
Here, there.
And we're going to call that biomes. And then we're going to go back down to our getVoxel function where we should have some errors. Yep. Just before the basic terrain pass, which is where we're going to put our, we'll call it biome selection pass. We're going to create a biome attributes, which we'll call biome to save all these errors. And then we're just going to say it to biomes, and right now we're just going to put O. Obviously we'll be changing that so it actually selects something shortly. And we'll go back to our world and we'll just put our default biome in there for now. Okay, so we're just going to rename this biome to grasslands.
My loads. My biome load. Updating my loads. Biome name. Grasslands. Okay.
I'll change that name as well, though it's not particularly important just yet. And then I'm going to duplicate it and create another one. So we'll just call this one desert. And if you give me a second, I just need to check which block is sand. So sand is 1, 2, 3, 4. So sand is ID 4. So in the desert biome, I'm going to set both the surface and the subsurface block to 4. I'm going to turn place major flora off, and then go back to world. Make this 2, drag desert in there, and then go back into here.
Oh shit, what is he doing? Block types, no, biomes. Plus. Grasslands, desert.
Yeah, and change this to 1. Sorry if I did that a bit too fast. So I just I increased the size of the biomes array, added desert to there, and then changed the biome selection here to 1, which is a second item in the index, in the array. So now we should have a desert instead of grassy lands. And there's no trees because I turned major flora placement off. And again, the lighting thing we will fix. I'm sorry about that. But the desert's a bit boring if it's just sand, so we could do with some cacti. So let's just go into our structure, and we're going to basically copy this.
Copy structure. The main reason I'm doing this, because I think at this point I could just start making my own voxel project, but I just want to keep going through this because I feel like it might be a good idea just to get some alternative views of how to do these things instead of just like blindly doing my own thing.
And we're going to call it make cacti. We're going to get rid of this part because this part is what deals with the leaf block. Leaf blocks, and we're not using leaf blocks. And then everything else is basically identical with the exception of this number here. This number is telling it what block that we are setting this current position at. Now at the minute we don't have a cactus block. So let's fix that. So I've already taken the liberty of adding the cactus textures to our texture map. That obviously will be in the download link with the video. I'm not going too crazy with adding blocks to this yet because we are going to do a little bit more work on our block data, a block types system. So that's why I haven't just gone ahead and thrown the whole texture map in there, because we are going to work on that a bit more. But for now, because we want some cactuses in our desert, some cacti in our desert, I've just added these 3 textures. So now that we've got them,
and I don't want infinite world generation. What I do want to do is I want to generate a world. Like, I'm fine with generating a lot of things on the go, but I want to like have a basic land structure pre-generated so that water has somewhere it can settle. Because I don't want to generate water on the fly, because it has a lot of issues. Like, if you have water physics and you have water flowing in certain directions based on like elevation, and maybe it's like melting from somewhere and coming down or whatever. I don't know if this is viable, but... And then it flows out, and it flows out into somewhere that hasn't been generated yet. Now you have an issue, because that might be flowing down into somewhere where it pools up. So if you have to generate that, is it just gonna start dribbling down into there, and then eventually it'll fill up into a lake? Because like you have to basically generate a lake on the fly that way. And it gets weird. So that's why I want to settle liquids and stuff like that beforehand. when you generate the world. But the question is, in practice, like how will this kind of stuff work out? But that'll be interesting to play around with. I'm also very interested in the cellular automata. That's like what I'm most interested in, because it's not just water. You can do a lot of things with it, like you could add like mass and hardness to any block if you wanted to, and then you could toss a grenade, and you could make the grenade add force into a tile, and then you spread that force, and then you could make like stone tiles, for example, have a certain resistance, and if you overcome that with this force, then you can either move it or destroy it or something like that, or move a certain amount of stone into another block, and you could create really cool things that way. And the same thing with water. Like, one thing that I want to do, like one of the most basic things that I want to try implementing is, if you place a block in water, that should add force in every direction. Because it's like you threw something in there and just see, like, get some ripples in the water or something like that. But I'm getting ahead of myself.
We can go into Unity and into our world, and we can add 2 more block types. Actually, let's make that 1 more block type.
All right, I need to put this in. Let's see. Assets, textures. We are at episode basic biomes. Textures. Replace everything, yes. But it looks really fun. Like, I don't think things are fun often, but messing with the cellular automata stuff seems like genuinely like a lot of fun. And the same with I'm also very interested in generating weather patterns. Like, I don't even, like, it'll be very hard to even test, but I've been thinking how to, like, do it internally as well. And I'm thinking of having a couple of threads run at all times that just handles those kind of things. And like a low priority thread that just updates low priority shit, like physics and stuff that isn't near you, and it can just update that slowly around the world and kind of, you know. But also trying to generate weather patterns using like Hadley, what are they called? Hadley cells or something, where you've got perspiration and like rotational forces up in the atmosphere to like create clouds and weather patterns and stuff. Would be fun, but if it's practical, who knows? But I still want to try it. But I think water physics is probably going to be the most fun part, because just making tons of water move around is pretty nice. However, the issue is making tons of water move around performantly.
Cactus. We want the transparent.
He's adding stuff here. Block types. And now he's got 13 block types. Wow. After leaves, we've got cactus. And it is solid transparency.
To be 0. Haven't got an icon for it yet, but again, we'll fix that. If I just pull up our block atlas again, so we can see that the cacti textures are 17, 18, and 19 in the ID positions, because it's 0 to 15 on there, 16 is the leaf block, and then 17, 18, 19. For now, we're only going to use one block, so we're only interested in 18 and 19. 18 for the sides, 19 for the top and bottom. So 18, 18, 19, 19, 18.
18, 18, 19, 19, 18, 17. Oh.
18. And then
18.
just because we're here already, I'll add another one which should copy those same values. And that one is going to be called cactus top. And the only difference is that the top is going to be 17, although we are not going to be using that at the minute. The cactus block is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So then we want to set this to 12 instead of 6. And then
Well,
up here we need to account for cacti. So case 1, return. In fact, let's just copy this. Make cacti. Now in our world script, we need to also use this. So instead of calling, where is it?
3.
Instead of calling here make tree, we're going to go back to structure and remember what I called it. Generate major flora. And then obviously we need to give it an index. And then for the index, we're going to go over to biome attributes and we're going to put an index in here.
Biome attributes. Major flora.
So public major flora. Give it a semantic name. And then in here, we just need to say biome dot major flora index. So now let's go back to our 2 biomes and we should have an option here. So for desert, that's going to be 1. And then grasslands obviously is trees. So that's that.
Major flora. Desert. Major flora 1.
It just stays at 0 because that's the first option in the array. So let's change that to place major fauna true, and we'll change our max height to, let's see, we'll go between 4 and 2. And then also I just want to go in here and change this offset value so it's not using the same offset and scale as the trees.
Where is structure? Oh.
So it doesn't really matter what it is. I'm just going to go that. That's fine. And for scale, I don't know, 2. So let's just see what that gives us. Okay, so the cactus placement is working, but for some reason we've only got a lot of single block high cacti. So let's just change that. We'll set that to equal the height as well as... Right now it's set to go between 1 and less than height, which means it's essentially going between 1 and 3 instead of 1 and 4. So we'll make that equals, and then also we'll increase this to 5. So now we have some cacti that are actually taller than 1 block. And again, this, like I say, I'm not trying to show you exactly how to do everything. I'm just trying to show you enough for you to be able to run away with it and do your thing. So we have, you know, the makings of another biome, but now we need a way of implementing that. So if we go into our world and we go into our get voxel function and find our biome selection pass that we created earlier on. Now what we can't do is this. So let's just say we set int index, and then we say if noise.get 2d perlin new vector2, and then we pass in posx and posz from the value that the voxel that we pass into the get voxel script, and we give it a random offset and a scale of 2, and we just say if that is greater than 0.5f, index equals 0, else index equals 1. And then we move this down here And instead of setting it to a particular number, we set it to index. So what this is going to do is it's going to do a noise sample check, like what we do to get the height of the terrain and things. And then it's going to say if it's less than 0.5, it's going to be 1, and if it's greater, it's going to be 0, so grass or desert. Now here's why we can't do it that way, or why it's not that simple. And for to properly demonstrate this, I just need to change these values here just a little bit. So I'm going to make that...
Changing the desert. Rain scale.
0.55. And the reason for that is it needs to generate different terrain for me to properly demonstrate why this won't work. And terrain height we will make, I don't know, 18. So this is why we can't do it this way. Now as you can see, well, for one thing, the biomes are very small. That's each one of these patches of Greenland is technically a biome. That's just a scaling issue. That's easily fixed when we do the proper code. The problem we have is the heights. So because we've got it generating different terrain, the biome at this particular point here is this high, whereas the desert biome at that particular point is this high, which obviously causes a problem. So we need to fix that. That's why we can't just simply say, is it this biome or is it that biome? So let's close that. So the first thing we're going to do is this solid ground height in the top corner here. We need to get rid of that. So if you remember, the way we did this is the solid ground height is basically that is going to be solid no matter what is going on with the terrain generation. It's always going to be solid up to that amount, so 42 blocks. And then this height above it, the terrain height, that is going to be from wherever the solid ground leaves off to that is the maximum height. So 42 plus 18 is the maximum height the terrain can be for this biome. And then the purling noise works within those 18 blocks and gives us undulating terrain. Now we can't be having this 42 being different between biomes. It needs to be the same for the world across. So if we're going to have it 42, it needs to be 42 regardless of which biome we're looking at. So we're going to get rid of it in here. And then we'll go back to world, and here will do. We're going to say int solid ground height equals 42, and we can put that somewhere better at a later date, but for now it'll do that. And then wherever we use it, there is an error somewhere. We can just delete the biome reference, and that should work. So now, finally, to make it work, if we go to our little test code here, you can see that we have our position, pos x and pos z, that we get by default because we're in the get voxel function. And then we're also handing in an offset and a scale. Now we need those two values and they need to be different for each biome. So the first thing we're going to do is put that in there. So we'll stick a new header up here where we've already got biome name, and we're going to put a public int called offset and a public float called scale. And they're going to be different for each biome. Then we'll go back to our world, and we don't need this now, so let's just get rid of that. So,
Hold on. Go back. Biome name, public int, offset, public float, scale.
And they're going to be different for each biome. Then we'll go back to our world.
Go back to our world.
And we don't need this now.
We delete all the things we just made.
So let's just get rid of that. So let's get started. Now, basically what we're going to do here is we're going to sample each biome's noise value at the particular point. So in this case, we'll just comment that out until we've got a value. So in this case, let's assume that we have both desert and grass biomes overlapping. What we're going to do is, first off, we need to work out which biome has got the strongest value. So we're taking Perlin noise samples. Perlin returns a value between 0 and 1. We need to know which value has the higher value from that. That is the terrain that we're going to be getting our blocks from. But then the other thing we need to know is what height our terrain needs to be at. Now the way we're going to get that is we're going to add all the heights together from the various biomes. Right now we only have 2, but you could theoretically have 7, and they could and they almost certainly will all overlap in places, even though some of them will have very, very low weights. So what we're going to do is we're going to get a height for each of them, and we're going to add them all together and then divide them by the total amount of biomes at that given point, and then that will give us a height that is smooth between biomes. It also sort of flattens out things because you get the lower weights bringing down the lower heights bringing down the higher heights, but in general it means that you get smooth transitions between biomes in terms of height. And you can do things like you can add animation curves to make it more pronounced, but for now we're just going over the basics. So for these we're going to need a float. We're going to call sum of heights, which is going to start off as 0. We need a count, which is also going to start off as 0. So the sum of heights, we're going to add all our heights together. The count is the amount of heights that we've added, because obviously once we've added 2 values into sum of heights, we've got no way of checking how many values we added into it to get the amount that's there. So count is for keeping track of that. And then we also want to know which one was the strongest, and we're going to do that with 2 values, float, strongest weight, and int, strongest weight index, and these are both going to start off equaling 0. So now we want to loop through all of our biomes. So for int I equals 0, I is less than biomes.length I++, and then in here the first thing we do is we're going to get our biomes noise value. So float weight is what we're going to call it. So weight, because the higher this value, the stronger the weight it is. For people who've played around with Unity's terrain system, think of it as kind of like a splat map-ish, but a very, very, very basic implementation of it. We're going to get that value from our noise function. So noise.get 2D purlin, and we pass in our new vector2, pos.x, pos.z, and then we're going to pass in our biome value that we just added. So biomes, whichever the current one is, offset, and then biomes, whichever the current one is, dot scale. And then to keep track of weight, just put a bit of commenting in here. We're going to say if weight is greater than strongest weight, which the first weight we get will be the strongest because we've set it to 0.
I kind of understand what's happening now, what he's doing.
Then strongest weight equals weight, and strongest biome index equals I. Strongest weight index, sorry. Actually, no, biome index is a better. I was right the second time. Yeah, biome index is makes more sense. So then we want to get the height of the terrain. And multiply it by its weight. So to get the height, float height equals, I should be able to steal some code from down here somewhere. Yeah. So this bit here, we'll just steal that. And then where we get these errors here, we're going to replace that with biomes and the
Float height equals this.
index. So that gets us our height.
Holy shit, when he typed that, he like pressed every single button wrong.
And then what we want to do at the end is multiply it by the weight that we got. Now, remember...
Wait, it says biomes. Biomes.
The weight is a value between 0 and 1. So it's essentially like getting a percentage of it. So if it was 0.8, timesing it by that gives us 80% of whatever the value was. And then the next thing we want to do is, if the height value is greater than 0, because we're not interested in anything that's less than 0, add it to the sum of heights. So if height is greater than 0, sum of heights plus equals height count plus plus. And then after that, We want to set our biome. So biome attribute, oh, actually we've already got, we'll just use this code here. And then obviously we're setting that to strongest biome index. So regardless of what the height is, the blocks that we choose will be coming from this biome. And to get the average of the heights, we're just going to do sum of heights divided by the count. And then finally, actually, these should be outside of the loop, sorry. My bad. And then finally, we're just going to delete this line here because we're replacing it. Int terrain height equals mathf.floor to int sum of heights plus solid ground height. And that's why we need the solid ground height to be the same for all of them, because we've got this value that we're working so hard up here to keep consistent and smooth between the biomes so we don't get those weird steps. If we then go having this height be different between each one, then we're still going to get those weird borders. So if I go back in here now and I give these a value, and you know what, I've got some pre-made biomes I'm just going to drag across to save messing around with these values because I can't remember what my old one were. So I've dragged these biomes over.
Desert, forest, grasslands. I should have those too. Let's see. Assets. Woo. Data, biomes. Basic biomes, assets, data, biomes.
Over that I made when I was doing some testing. I'm not sure if you're interested in the values, but that's desert, one that I've called forest, and one that I've called grassland. So I'll just nip into the world here, increase the size of our biomes array, and drag in these biomes. And if I press play, we should find that our biomes now
Huh? It's broken because I don't think my scriptable object is exactly like his, most likely. Scripts, biome attributes. Going to back those up though. Put them down there. Then we put those in there. There. And then my biome attributes, he called them min height and max height. Somehow he managed to find a way to get those things to fuck up because I named them something different. I was like, this doesn't matter at all. But of course it did. So now we go in here, we do like that, grasslands, desert. Forest, desert. Why won't the desert work? Desert broken? It is, because I was clicking on it. See, data, biomes, desert. There. desert.
Smoothly transition between each other. Now, as I say, the terrain is kind of flattened out or smoothed off, maybe. It's most of the excessive features, like if you had like a really tall patch from the forest, which I have the forest biome, which I have set to be a bit hillier and have a bit more variation in the land than the desert, which is set to be pretty much flat. It all gets sort of like squashed out to be fairly uniform. But like I say, this is basic biome terrain generation, so we're going to get into stuff like that at a later video when we start to get into the more advanced things. So that is your basic biome generation. I'll just zoom out a bit there. And if I temporarily nip into our textures file and change this so that mipmap is not enabled, we can see everything. Mipmap, by the way, it generates textures. When you get a texture, it generates like a lower resolution texture that can be used for a distance. So it's kind of like level of detail preloading for the texture specifically. But obviously, when you're using 16 by 16 textures, there's not much shrinking down that can be done. So it kind of just disappears in the distance. So if you turn it off, you can see all further away, but you kind of get this weird noise effect in the distance. But there we have it. So as I say, the next Minecraft video, fingers crossed, if things don't go all to pot, will be the finishing of the lighting video. I was hoping to do something Halloween themed next week.
This is pretty nice.
This week, depending on, because you'll probably be watching it this week. I haven't decided what yet, but so the next Minecraft video might not be next week or this week, whichever week it is, Halloween week. But it will be the next Minecraft video. Even if that next Minecraft video gets delayed for years. Yeah, that won't happen, by the way. But yeah, so thanks for watching. Sorry about the lighting video. Hope you enjoyed this video. I will see you all next time. Bye-bye.
Bye-bye.
And obviously I can't end the video without saying a huge thank you to... So click that checkbox.
Texture Atlas Packer. Fuck that. I don't give a shit. I'll be right back. Oh, boy. Oh, I really. Oh. Need to learn to make 1 cup of coffee. I always make 2 cups of coffee, and then I drink. And it's too much coffee every single time. Like... Ugh. I've had so much sugar over the weekend. Oh my god. It's not worth it. It's... I don't know. I had everything. I had sugar, and I had like potatoes and rice and everything. And I don't miss it, to be honest. Like, I don't want to go back to eating it. I kind of miss pizza a little bit, but that's like just because it's shitloads of cheese. Cheese is nice, and tomato is nice. But like, I can kind of get the same experience as eating pizza, to be perfectly honest, by just putting like a bunch of cheese in like the frying pan and like popping some salami into it. Broccoli and pasta. Yeah, it's all right, but you don't miss it as much as you think. At least personally, that's how it is. Like, I did think I would miss things a lot more, but once you haven't had them for like 3 months, and you go back and you're like, you notice how much worse it makes you feel, and you're like, it doesn't really taste that amazing anymore. Like, I can live without this. I don't know. Because the things you can eat are still really good. And I still eat like onions and garlic and stuff. Like, I still get milk, I still get cheese. I can still fry the cheese. And this is sour milk with a bunch of sugar in it, and it tastes like apple and cinnamon. It's worse than just normal, like just unflavored normal sour milk is much better, and it's sweet as well. This is just way too much. Plate of garlic I saw on Twitter last night. What? Actually, I wonder what garlic tastes like if you like slow heat it, like you do with onion. Sour milk. I don't know what buttermilk is. It's called filmjölk. Google it. It's just a type of yogurt, kind of. It's the same kind of thing. It's just fermented milk. You just call it sour milk. We don't call it sour.
Click play. We'll set all the values different to what they were, so enable threading false, chunk animations true, mouse sensitivity 1.5, view distance 21. Click done. Hello, and welcome to the latest episode of How to Make a Game Like Minecraft in
45 minutes. Oh,
Unity.
shit.
In this one, we are going to be doing a main menu / settings menu. Obviously, I'm going to try and copy Minecraft in the way I do it, but you will want to do it your own way, because if you guys are making a proper game and you put it out looking exactly like Minecraft, you're going to get sued. So, first thing we're going to do is I just want to bring in the TextMesh Pro package. I know a few of you have said that I should have done this already. I hadn't at this point until now thought it was worth it because it just makes the fonts look better and we're not really using any fonts. But the reason I'm bringing it in now is because we're going to want font shadows, and we can do that without TextMesh Pro, but it would mean having two sets of fonts, like one on top and then a darker one underneath. And then obviously we would have to update both sets of fonts, which is a bit of a hassle. So if we just go up to Window up here and we want to go to Package Manager, and it's not going to show many packages to start with. Click on all packages.
I'm already using PMP or TextMesh Pro, so I don't need to do this.
So now we've got all packages, and we want to go to TextMesh Pro, which should be in the T's, you would think. There we go, and just click install there. Okay, and when that's done, we can close that window. The first thing we need to do with that is we need to create a new, where is it? It's up here somewhere. A new font asset, because you can't just drag a font file.
It's basically yogurt, but it's a little runnier. Pretty much. But even between yogurts, it's like a completely different product. Like Greek yogurt and Turkish yogurt, completely different yogurts. Like, you call them yogurt, but I think like both of them are so different that you can't just say yogurt about both, really.
TextMesh Pro needs a specific type of font asset.
This is way different from that.
Basically. So if we go to TextMesh Pro, font asset creator, and then it's going to ask us here, do we want to import the essentials, which we do. And we can close that. We're not bothered about the examples and extras. And then up here, we're going to pull in the Minecraft font that we've been using. You can leave all these settings as they are. You can mess with them if you want, but they're fine for what we're doing right now. Click Generate Font Atlas. As you can see, it's created this texture map thing here. And then save it, and we'll save it in the fonts folder. We'll just leave it the same name. And there we can now use that font with TextMesh Pro. And the next thing we need to do, which I've already done because I've already dragged some files in,
American yogurt. That's just yogurt with corn syrup or something.
A UI folder in our textures folder for these two files, which we will be using shortly, but it's basically just a button and a text box texture. We're going to need a new scene, so before we get a new scene, let's try and keep things nice and neat. So,
all right, fine. What did you just do? He has another font. Let's see. Literally. Yeah, I mean, I don't buy sweetened yogurt. I buy the natural flavored ones. Just no flavoring, no added sugar yogurt. High fat. For the Greek ones, there's mild yogurt and there's normal yogurt. The mild yogurt is a lot better in my opinion, but I honestly prefer this Filmjölk. So now we go into 21. He's got textures, UI. And he has fonts. He's got a Minecraft font. Pop that in too. There. And now he is in the font asset creator, TMP font asset creator, Minecraft CHMC, auto sizing 5, fast 5112, ASCII, generate font atlas.
And then save it, and we'll save it in the fonts folder. We'll just leave
save, and that's the SGF asset.
Leave it the same name, and there we can now use that font with TextMesh Pro. And the next thing we need to do, which I've already done because I've already dragged some files in, is I've created a UI folder in our textures folder for these two files, which we will be using.
And like I said, I am just trying to get through this so that I can also do game development in January, during Game Development January. so that I'm not just sitting here watching Minecraft videos while you're sitting there trying to actually game dev. My idea was no game streams for all of January. Only game dev streams for all of January.
Shortly, but it's basically just a button and a text box texture. We're going to need a new scene, so before we get a new scene, let's try and keep things nice and neat. So we're going to create a scenes folder, and we're going to drag our main scene into the scenes folder, and then we're going to create a new scene in the scenes folder.
I have the first 2 weeks. I'm not sure what I should be accomplishing. Well, you better start thinking. The problem is that the first step is the most boring one. Like, it's not gameplay for the most part. Longest vacation I've had in at least 5 years, and you're gonna spend the entire thing working.
And we'll just call it main menu. And we'll open up that scene. Now we can.
Alright, so are we in sample scene right now? Yes, we are. Let's call this Minecraft. No. Save that. What happens now? If you don't work, you can't enjoy anything else anyways. That's true. That is true. It depends on what you're doing, but yeah, I agree. However, like, everything I've been doing on Legends of Terrestria is not interesting, and it makes me just want to shoot myself in the brain. So I'm so tired of it. Holy shit, I just want to get past it. Oh, there? Oh, it's just a bunch of roasted garlic. Yeah, see, that's what I'm kind of wondering. Like, what would that taste like? I kind of want to just go buy a garlic and just put it in a form in the oven for a while and just see how it tastes. Because, like, eating raw garlic or just raw onion is terrible. But if you put onion in the oven for half an hour, it tastes amazing. So, like, maybe garlic that way is actually really good. Wonder what kind of, if he has like some fat in it or something. Lightly sweet / spicy, I think, same as garlic. Yeah, it would probably taste like garlic, but probably, like, if you can get past that or get rid of that dog shit, like, this burns your face off feeling when you're eating it, you know, might be good.
Delete directional light because we're not going to be using any kind of lighting or anything in this one. And the first thing we will do in our new scene is we're going to create an image. So go down to UI.
Yeah, I kind of want to do that. How do I remember that? Go to my desktop, new folder, buy garlic. Okay, there. So what are we doing? We're making a new scene called main menu. Right.
Go to image.
So we're in here now. We've got our main camera. Create. Yeah, but I don't want to make 4 heads of garlic. Just maybe it tastes like shit. Maybe it's just not good. And I'm probably gonna fuck it up. Need an image.
And we want to set this to stretch. So if you opened up this menu here, so the one we want is this one down here, and if you press this one down here, and if you press Alt, you can see it's automatically set to stretch to the full extremities of that current, of whatever that layout is. In this case, all four corners. So click that, and it automatically stretches it out to all four corners.
Never seen this before.
Obviously, white is a bit dull. As I'm copying Minecraft for this video series, I'm going to go with the Minecraft standard sort of settings menu. So if we go into, if I could just remember where I stored it, we go into Resources, Atlas Packer, and these are where I have all the individual textures for our texture atlas. As you can see, we have dirt here, so I'm just going to duplicate that, and we're going to drag that into our UI folder, and then we can just call it...
Did I teach you my Martha Stewart method for getting the cloves out? No. I have seen videos for it, but I didn't understand at all. Like they kind of just like rip them out of the thing, the bulb. But I think it has to be really fresh for that. Textures. Basically just put them in any enclosed hard space and shake them. Oh, okay. Put them in a box and shake them. I see that, because I always, I cut the bottom little bit off and then I just crush it a little bit. What am I looking for? Textures. UI. Menu BG. Yeah, okay, he already gave me that. Good. Because I didn't want to bother with his texture packet bullshit.
Menu BG. And we need to change what it is. So instead of it being a default texture, it's going to be a sprite. And we want to change tight to full rect, just because apparently sometimes it can cause issues. I didn't come across any issues myself, but apparently it does when you use it the way that we're going to use it. Make sure we've got it on repeat this time, and we want it on point. And then you can change these as well. It don't really make a difference, but...
He keeps changing this. But I don't think this matters at all, in the slightest, for anything. This, the max size, this is like for building, if I understand correctly. Like if you have a PC project and you have it so that you have it to 2048 or whatever, this is the default max size. Generally, if it's on PC, like you wouldn't even want to do this, but it's so that if you're gonna put your project on mobile, for example, you can have it like set to 512, and then no matter what size everything is, or your textures are, it'll use the Mitchell resize algorithm to like just compress them to 512, so that you can just export it and it runs right away without it. But it doesn't like make your textures use any less data or anything by setting this stuff. Or at least I can't imagine that it does.
We want compression on none, because it's a 16 by 16 texture. You can't really compress it anymore, and also compression can mess with it and make it look wrong. And then with our image, we're going to drag that into there, which obviously that doesn't look very good at the minute, but we can go down to here and we can say tiled, and now it is closer, but still not quite right. So we can change this to make it fit our needs more. Obviously 2 is the wrong direction, so let's try 0.4. 0.5? Go 0.5. Okay, that works for me. So the next thing we're going to do is, well, actually, first thing we're going to do is rename that to background. If I've not covered this before, or if you've not worked with the UI system before, things will be...
Why is it so fucked up? Oh, because I'm making it smaller. 0.5 there, yeah. We have to divide it.
Drawn in the order that they are under the canvas here. So if I created let's just duplicate this one, and we will tint it red, and then we'll make it 200 from the left and 200 from the right, so you can clearly see it. Now this background is first in line, so that gets drawn first. This one's second, so that gets drawn second. However, it would be reversed if I move this above there, and now you can't see the red one because it's been drawn before the other one, which goes over the top of it. So if you ever create a new text UI element in your canvas and you can't see it, check what order you've got it in the hierarchy, because that could be what's causing it. So we'll just get rid.
Martha shares her new and improved
When you're
method.
faced with a hard head of garlic like this, take yourself a covered bowl jar like that, and hold the garlic like that, and
Whoa.
smash it with the
Whoa,
jar.
whoa! Whoa! Don't smash it with a
Break it
glass
all
jar.
up into all the different cloves. Look, all the cloves are all now nicely broken up. And take off the heavy outer coating. This garlic is all in my corn crib drying. If you look at my Instagram at Martha Stewart 48 Instagram, you will see our beautiful garlic drying in our corn crib. And let me just smash this again.
Ah,
There.
stop.
Much better. So now put all the garlic cloves unpeeled, devoid of some of that outer coating, because that's a lot of coating. Look at all these beautiful garlic skins. Put them in the jar like this. Now I remember showing you this using two big stainless steel bowls together. But now in a new and improved version of the shake and peel. It's called shake and peel. Just shake that jar really hard. Makes a lot of noise. Have you seen this, Ryan? Wait till you see this magic. I love this stuff. Now your cloves and garlic are all beautifully peeled for you, and you don't have to deal with, smashing it. If they're not peeled, put them back in the jar, and, because I had a lot in there,
Take
and
some more.
just shake it again. Oh, here, this one's all done.
All right. Didn't know that. But I also never made garlic in the oven. Holy shit, the humidifier is like 4 times as big as I thought it was gonna be, to be perfectly honest. Fucking huge, dude.
Of that red stripe that we don't need. So we're going to create a menu button. So we go to UI and we want a TextMesh Pro menu button, because we're using TextMesh Pro, we may as well use it all. And over here for these two, we need to do the same thing that we did before. We need to change them to sprites. We want that to be full rect. And then if we go into our button and we pick the button image and drag.
I got the Philips. It's a Philips. It's one of the Philips. I don't know which one though. Can't see from here either.
That in there, you can see that looks absolutely terrible, and that's because it's been stretched. So if I made that 30, it still looks kind of terrible, but at least it's terribly proportioned evenly. Oh, that's sorry, the other thing is we need to make this, we need to set all these as well. This one doesn't need to be repeat because we're not going to be repeating this one. So that's fine there like that, but obviously that's no good because the text won't fit. So let's for now just make that 200. As you can see, it looks better now that we've made it point, but it's still stretched to all hell. So if we go down to here and we change this to sliced, and it's giving us this error saying it does not have a border. And that's
Just make sure it's either running or empty. Yeah, that's fine. Or that's fair. Water does get icky if it's standing around. It's probably one of the worst things to keep around. Yeah. I see that. It does say antibacterial, so I don't know in what way it is, but that's what it says. But mold isn't a bacteria. What are we doing? Oh shit, I'm so lost.
Because we need to go into our button, and I don't know if we can do two at once, so we'll just do the button for now. And we want to click Sprite Editor. And as you can see, we've got I think we've used a Sprite Editor before in another video, but if not, this is a way you can just cut up, like say a sprite sheet. You've got an animation of a little walking character, you can cut it up into individual sprites. And we want to drag in these. So our border is 2 pixels, or is it?
Yeah, I
4
know how
pixels?
to make a nice
It's 4
slice.
pixels wide. So it's the black outline plus the sort of embezzle shadow, or bezel.
Honestly, the
bevel-
current
bevel-
videos
bevel
are
shadow.
really
I know words.
uninteresting because
And then
it's
same
just
for here and here.
it doesn't have anything to do with
it's going to
voxels.
keep
it's just
this
like this
outer part
trash around. But I feel like I have to
So
do
when it
it.
stretches things, it's only going to
Otherwise,
stretch this
I'm
middle
gonna
part. So if we click apply now, and we'll
be
leave
missing
there,
stuff.
you can see it looks a lot better. And then just while we're there, we'll do the same thing with this one. Although we're not using it just yet, but we do need to do it, so I may as well do it now. We'll go into the hierarchy and pull down the button, and we can see we've got a text object, and that is the text in the actual button itself. So let's change that font to Minecraft. We'll make it, I think 28 was a good size. We want it to be white. And if we scroll down, we've got all these extra settings here. And the one that we're interested in is underlay, which another way you can think of it is shadow. Enable.
Underlay. I thought it had like a thing here. For these kind of things.
That one. Let's just make it solid, fully transparent, fully opaque even. And then give it the maximum offset, but in the other direction. And if you want, you can make it a little bit fuzzy, or not fuzzy at all. I think
We're gonna dilate it? Hell yeah, dilating the shit out of it.
it looks fine if we just leave it there. Sorry, this one's the fuzzy one. That's entirely up to you. I'm just going to leave it like that. And then also, because it seems a little bit out, I'm just going to move it up a little bit. About there.
Moving it up a little bit. Where are we moving it up?
-3. Yeah, -3 looks about right. There we go. We've got a button. So what we're going to do with that for now is we're going to go into our prefab folder and we're going to drag that in there, and then
I'm gonna make a UI folder. There.
and that's, we've got a prefab for buttons. We don't need to go through all that every time we want to create a button. So this one we're going to call Start Game, and we'll go into the text and we will rename it Start Game. Now our UI elements in the game that we've got so far, that is the toolbar and the inventory, we have scaled up to 2. So we'll do the same with this to make it a bit consistent. And then the next thing we want to do is we want to have multiple buttons, because we're going to have at least 3 options. We're going to have Start Game, Settings, and Quick Game. Now you could just put these, we could just duplicate this button, and then we could go up here and we could set the position to be lower like that. However, it's a bit rough and it's not going to scale well with different screen sizes, so we're not going to do it that way. We're going to create a new panel. I'm going to drag this above the game buttons, and we're going to, well, actually we're going to drag the buttons into the panel itself. We'll call this panel Main Menu, We go into the image here and we just make it fully transparent. We don't need to see it, and we can just set this to 0 because it's not going to have a background. And the reason we're not using this image to set the background is because we're going to have multiple of these. There's going to be one for the main menu and one for the settings menu, and you don't want the background flickering when you go between menus. And on this main menu object, we're going to add a component called grid layout group. Now you can see that's already made a mess of our start button. What this does is it creates a grid, and any child object with a rect transform, that's this up here, any child object with a rect transform will be modified to suit the shape of the grid. So currently our grid is set to 100 by 100. So let's change that to be, let's go 160 by 40 maybe. Yeah, that looks about right. And then we want to make it so that, well, first off, we want this to fully stretch to be the whole screen. So if we click on that, press Alt, and then click on that one. And then secondly, it doesn't matter about the start corner, but we want our axis to be vertical. We're going up and down, not left and right. And we want our alignment to be middle and center. So you can see it's already put it in the center. That's great. But the benefit of this is now that if we duplicate this button, it automatically slides that one up. Obviously it's not slid it up far enough, but we can change that by fixing this spacing here. So the button is 40 deep, so if we make it 50, that gives us a bit of a space between the button. So we'll leave that like that, and then we have this new button here, which we will call settings. And if we go into the text menu or the text object, we can rename it as such. And then we'll duplicate that one more time. Call this one quick game, go into the text, and quit. Now, it's not as straightforward as that when you start a game because you need to give the game a seed. Now, obviously, you don't want to have your player be going into the settings file and changing the seed here. Where is it? There. But also, the seed itself isn't something that you should have in the settings file in the first place because it's not specific to the overall game, it's specific to individual worlds. So we're not going to put in that in the settings page, and we're going to take it out of the settings file a bit later on in the video. But for now, we're going to create a text input field. So if we go into main menu, go into UI, and we want Text Mesh Pro input field. And as you can see, it's on
Main menu, UI, TMP, input field.
already screwed off into the corner, but that's because it's not made it part of this. There we go. So we drag it into our main menu. So this one's a little bit tricky. First off, we know the scale is going to be 2 by 2 by 2, and then we want to use our text box graphic the same way we did before. And if we drop this down, you can see we have a text area and we have a placeholder. And
We were putting what? Text box. Scale it up. Man, these should not be scaled. The main menu should be scaled. Well, maybe not. Fine.
a text. Now the placeholder is this enter text value here, and then the text is obviously the text that shows up when you type something. So first of all, let's use our Minecraft font. So we'll just set that to New World, and then make it white, obviously. And the size, I believe, was 28 that we've been using. And then the placeholder, well, you know what, we'll delete the placeholder because we don't really need a placeholder. There's always going to be a seed in there, and if there isn't a seed in there, we don't really need it to say an example. Then if you go to input field, there's some values we want to change here. So character limit is the main one. Character limit I'm going to set to 10. You can set that to whatever you want. And then in the text here, I'm just going to put New World because otherwise it's going to update this text. It's going to update this every time. we want to drag this. Actually, we don't want to drag this.
Next area, where is it? Character limit 10.
Below. What we want to do next is create, because it's not immediately obvious what this text box does, so we need to create a label. So the way we're going to do that, so we can have it side by side, is we're going to create another panel, which we're going to drag up above
UI panel.
Not into settings, just above settings and below start game. Again, we don't want any background image. And then we're going to drag our input field into this panel, and we want to set this to maximum size. Panel actually wants to be 2 by 2 by 2, and our input field can remain at 1 by 1 by 1. There we go. So now that's in a panel. So what we can do in this panel is we can create another label. So UI.
Why the fuck did it get changed back? Oh, that's because I have this background here. Huh? Super confused.
Text Mesh Pro text.
Go back. Back.
And in the text here, I'm just going to put new world, because otherwise it's going to update this text. It's going to update this every time. We want to drag this. Actually, we don't want to drag this below. What we want to do next is create, because it's not immediately obvious what this text box does, so we need to create a label. So the way we're going to do that, so we can have it side by side, is we're going to create another panel, which we're going to drag up above not into settings, just above settings and below start game. Again, we don't want any background image. And then we're going to drag our input field into this panel. And we want to set this to maximum size.
Oh no. There.
Size. Panel actually wants to be 2 by 2 by 2, and our input field can remain at 1 by 1 by 1. There we go. So now that's in a panel. So what we can do in this panel is we can create another label. So UI, Text Mesh Pro text. We want to align this to the left. Obviously we want to use our Minecraft font. We want to, we keep it left aligned, but we want it centered top to bottom. The font size was 28. We're just going to call this Seed. And then this is currently was it 200 wide? Let's try it. Does 50 fit? 50 fits, but obviously it's moved off to the center now, and that's because we have a position here. So set our X position. Let's set our pivot here to 0, so we're working from the left hand side, and then we'll set our X position to 0, and that means that it's always going to be at this side. So we have a width of 50, which means if we go to our input field and we align this one also to the left, and we set our pivot to 0, but instead of putting X fit.
Hello, Gunpopo. Oh, literally me when watching Bracky's vids. I'm just I've already done a lot of research for making voxel stuff and whatever, but I kind of just wanted to blast through this tutorial for Minecraft just to get a little better grasp of just kind of how it's done in general before I start just making it from scratch. So I just want to have a little bit of a framework in my brain.
0, we put X50.
Yeah, it's one, not one. So what is he doing now? He's like I just said, I hate these parts because we're just doing the UI stuff and like saving and loading and whatnot, and I know how to do that already, and it has nothing to do with anything. So see, I love UI stuff. You're insane. So okay, let me go back.
Moved off to the center now, and that's because we have a position here. So set our X position. Let's set our pivot here to 0. So we're working from the left hand side, and then we'll set our X position to 0. And that means that it's always going to be at this side. So we have a width of 50, which means if we go to our input field and we align this one also to the left, and we set a pivot to 0, but instead of putting X0, we put X50, it means it's going to start from this edge. But now we have it overhanging here like that, which obviously isn't ideal. So the way we can fix that is if we go, instead of align to the left, we go align to the left and right. So our position is going to be determined by its distance from the left and the right of its containing rect, which is this panel here. So click on that. Again, it's stretched to the side, but now we can press 50 there and it's constrained. Right is 0 from the right hand side, and then left is 50 from the left hand side. And you could have that if I...
Okay. And this panel should be like that.
Increase this number, it's going to get smaller. However, if I go into minus numbers, it's going to go outside the rect. But we're fine with just 0 for now. So we've got our seed, we've got our new world start game button, we've got our settings button, and we've got a quit button. These aren't going to do anything, but they all work. You'll notice that it sort of grays out when I click on things, and you have an animation for hovering and for clicking and everything. That's determined by these colors here. If you wanted, you could change this to sprite swap, and you could have a different sprite for each one, and you could make something that looks more like the Minecraft one, where the bevel is inverted and everything. But color tint works fine for what we're doing in this.
All right, let's see here. Text. This text needs to be white. Anything else? Let's see. It felt smaller than the New World text, but maybe it isn't. But it needs to... Let's see. Parse escape characters. No. Do we have to go here? There's something that where you can say content type here. Integer number only. Now does that block me from typing anything else now? Yeah.
In this video. Now for the time being, let's collapse the main menu object, and we're going to create a new object, and we're going to call this one title menu. And this object is just to hold the script that's going to control this menu. The reason we're not putting it on here, for example, is because this is going to be getting turned on and off. So the way we're going to determine which menu we're in is this object here. We deactivate it. Bye main menu. So we can't put the script that we're going to use on there because it would get deactivated with the main menu when we go into the settings menu, and this is also going to control the settings menu. So we've got this object here. So let's go into our scripts. We will create a new folder for UI and try and keep some appearance of attempting to be neat and tidy about all this. Create our script. Again, we'll just call it title menu and open that up. Now we're going to need quite a few usings in this. It's not going to be immediately apparent why we need them all, but I'll put them all in now so I don't forget. So we're going to need Unity Engine .ui. We're going to need TM Pro, which is the Text Mesh Pro. We're going to need system.io because we're going to need to access the settings file. And we are going to need Unity engine.scene management. We can just get rid of these for now. So we're just going to create two public voids, one called start game and one called quit game. Quit game is going to be simply application.quit. That isn't going to do anything in the editor. I think I've covered this before, but application.quit only works in a build. It doesn't do anything in the editor. So if you try this and it's not doing anything, don't panic. If you want to see it in action, you'll have to build it. In start game, we're going to say scene manager.load scene, and the name of our main scene is main. And we want
No,
to
it's not. All right, fine. Fine, let's set it to that. I can change it.
Load scene mode single. So now if we go back in here and we drop down this main menu object and we go to start game and
Hold on, let's see. It's called Minecraft. Main. Let's call it main.
scroll to the bottom of the inspector, you can
Where are we? We are at start game. There, start game. And then we find on click.
see
Yeah.
you've got this on click event. So if we add an event and we drag in, oh sorry, we need to actually drag our title menu onto our title menu object. Now if we drag in title menu into this here and drop this menu down, you can see we have a title menu script, and in here we have the various functions that we can access. So we have start game because we made it public, which is another thing to note. If you haven't got this as public, you won't be able to access it from in here. So that is that. And then in quit game, we want to do exactly the same thing, but obviously with the quit game function. So now if we load a game, quit doesn't do anything, like I said, because we're in the editor, but start game should load as our world. And there we have it. Now let's get that settings menu going. So just to save a little bit of time, we're going to duplicate the main menu.
Name couldn't be loaded. It has not been added to the build settings. There we go. Still have really ugly blocks there. Very cool. Man. There's my mouse.
And we're going to deactivate the main menu for now. Now our settings menu, which we'll call settings menu.
Are we duplicated in main menu? Alright. Dupe. Settings menu. Enable that.
We're going to make a little bit different size-wise. So we're going to go with 30.
Grid layout group.
And spacing of 40, and we don't need this panel, and we do need a...
We don't need which panel?
And spacing of 40, and we don't need this panel, and we
don't need that panel.
need a title. We want to say that we're in the settings menu. So if we go to settings menu, right click, go to UI, Text Mesh Pro, drag that to the top, although it doesn't really matter because none of these objects are going to overlap, but why not keep it in the right order? Just say settings, select the correct font. Nope, that's the same one. The correct font, we'll set this to 28. That wants to be 2 and 2 and 2, so it's the same as everything else. Center aligned, and that will do for now. Actually, let's make it 24. And we're going to make all these that size as well. So the only button we're actually going to be using here is the done button to say that we're finished with the menu and want to go back to the main menu. So let's turn our quit game button into a done button. And then if we go back into our script, we can say public void enter settings, and then public void leave settings. And we want to take in two references, public game object, main menu object, and then public game object with only one T and no capital B's, settings object. And then in here, all we're going to do for enter settings is we're going to say main menu object dot set active false and settings object dot set active true. And then for the reverse, we're just going to copy that and reverse the values. And then we're going to here for our done button, which we may as well change the size of the font while we're here. 24 is about right for that size button, I think. We'll go down to our on-click event, and then this time, instead of quit, we want leave settings. And then for our settings button, add an event, drag in our title menu, and then we want enter settings. And then if we go to our title menu and we drag in the main menu object and the settings menu object, and we press play, we're going to be in the settings menu, but that's okay because we should be able to just click done and we're out of the settings menu. Then we'll click settings, back in, out, in, out, in, out. Let's go into our settings file and see what we've got. So we've got a version. We don't really need to, well, we don't set the version, so we don't need to add that into our settings menu, although you could have a little text box in the corner that says the version. That's entirely up to you. View distance we need, enable threading we want, mouse sensitivity we want, seed we're going to be getting rid of from this area, and then enable animated chunks. If you've gone through that video and done that, we're going to put that in here as well. If you haven't done that, don't worry, you're not missing anything out. So let's start off with view distance. So go into our settings, and below our text, we'll drag it to the right place in a second, we want UI. Now there's no Text Mesh Pro thing for a slider, so we just have to use the regular Unity slider, and we want to drag it to below text. So obviously that doesn't look very good. So the first thing we can do is we drop down this and we have all these different areas. Now the fill area is basically if you want it to change color where it's, so we drag it from left to right. The fill area would be the left hand side of the little toggle thing would be a different color to show that that side is full and this side is empty. That's not how Minecraft UI looks, so we're going to get rid of that, so you can just delete that one. The background is the one we're interested in.
You deleted fill area? All the Twitter friends telling me about what their dads do.
So for the background image, go find our textures, and we want the text box one. So go back to background, drag in our text box to there, and then for the toggle, so that's the handle slide. Is it handle slide? No, sorry, into the handle slide area, you've got the handle. For that, we're going to use the button. So it's looking a bit closer now. Next thing, the overall slider, we want to set to the same scale as everything else. And then for the background, maximize that. And then the toggle itself, if you want to mess around with the size of it, you can change the width. I'm going to change mine to 15 because I think that looks a bit better.
Holy shit, calm down. Handle 15.
And then what we're going to do is we're going to duplicate, we'll just label this heading so we know what it is. And then we're going to duplicate it and steal it and put it in our slider. And we want it maximum size, and we're going to have to drag it down below everything else, because as I said, if it's below something it gets drawn before it and then it will be covered up by it. So we want it center aligned there. I think we worked out the offset of -3 made it nice and central, and then we will say view distance and then a number. So that's how that's going to work. So if I press play now, it's not going to do anything, but we should be able to use the toggle. There we go. So now that we have that, and then a number. So that's how that's going to work. So if I press play now, it's not going to do anything, but we should be able to use the toggle. There we go. So now that we have that, we'll call it, actually, let's just call it slider first. Let's go into our prefab folder and drag that in there so we've got one.
All right, prefabs UI slider.
One of those as well as a prefab. Now we can rename this as view distance slider, and then we're going to duplicate that, drag it above the done button, and this one is going to be a mouse sensitivity. We'll just put mouse S slider, and then for the label we will just say mouse sensitivity and we'll make these a bit wider because the text is starting to encroach a little bit. Or we could just make the text a bit smaller, I guess. Let's do that. We'll go with 20 and do the same for the view distance. Make it fit a little bit nicer. The next one is a toggle, so that's just a simple on or off. So let's click on our settings menu, create another panel, set the scale to 2, drag it actually in.
Fuck. Panel.
2 there, and then we want no background as normal, transparency 0, and inside here we're going to create first off a toggle. So if we go to UI again, there's no Text Mesh Pro alternative for this one, so we have to use the basic Unity one. We'll click toggle. Now we want to replace this label with a Text Mesh Pro one, so get rid of that, and then again we will duplicate this heading and drag that into our toggle, align it to the left. So the background is the toggle itself. So if
When you say left, he just says left. There are like a million left. You mean that one? It's already aligned to that. You mean that one? Alt also set position. Okay, that's what that means.
if we give our settings label left hand offset of 50, 60, we'll go with 60, and then again we want to make it vertically centered. We will say what's this one going to be? Enable threading. We want it to be aligned to the left so that we don't have this happen. There we go, that'll do. So as for the toggle itself, obviously this doesn't look very Minecrafty, so we'll go to the background, and all we're going to do is we're going to drag in a text box background for the background, and then for the check mark itself we're just going to use the button. Just to make this a
Nah. Xbox. And then the check mark is the button.
a little bit more obvious that it's a checked checkbox. You can give this a bit of spacing. That's the position. We want the width to be, let's say, 15. Yeah, that looks good. So then if you press play now, you can check and uncheck that. And these both slide, and then you can click done and come out of there. So just for now, let's deactivate that and reactivate our main menu, and let's start making all of this work. So it makes sense that we start with the main menu, and the only thing that we really need to do in here is get this seed value working. So in order to do that, we're going to open up our world, and we also want voxel data. So in voxel data, we're going to set a public static, but importantly not read-only, int, and this is going to be called seed. Now, the reason we're doing this is because static classes carry over between scenes. So this voxel data .seed is going to be equally accessible from the main menu as it is from the game. So if we set it in the main menu, then we can access it in the game. And that's how we're going to pass that data between. Like I say, it's game dependent, so we don't want to be putting it in the settings menu because you might have a different seed the next time you load the game. So it doesn't need to be in the settings menu because it's not going to be staying the same all the time. But there is something that a couple of you guys have noticed, which was a slight oversight on my part, which is that I actually forgot to implement the seed value in the Perlin noise itself. So first off, let's just go into here. I think, have we already taken seed out? No, we haven't taken it right. So we're taking seed out of there. That should give us a few errors, or at least one error. So now instead of settings.seed, we're going to say voxel data.seed. And then we're going to go over here and we're going to open up our noise script, and we're going to implement
God damn it. Oh, I managed? Okay.
the seed function in here. So position.x plus equals, and then we're going to say offset plus voxel data dot seed plus 0.1f, and then we can just do away with the offset here and do away with the plus 0.1 there, so it's all handled there. And then same at this side, get rid of the offset. Get rid of the plus 1, and then duplicate this, obviously. Point Y, and then all that stays the same. So that now implements the seed into this part, and then we want to do it down here, but for down here we can just copy this because we're already modifying the position values at the top. So plus that, and plus that. So that's that. So now our seed value will be taken into account. However, we need to pass it over from the title menu. So what we can do is in start game, we're going to say voxel data dot seed equals, and now this is, I'm going to have to explain this a bit. So first off, in here we can put numbers and letters, but our seed needs to be a number. So to get the number, we're going to say seed, oh no, sorry, first off we need to bring in the seed field. So let's just say header main menu UI elements, and then we want text mesh pro UGI, and we'll just call it seed field, I guess. Yeah, that's fine. Seed field, and we want to make this public so that we can drag it into the inspector. And then here we're going to say seed field dot text dot get hash code. There's only one bracket there, sorry. So if we go into our world now, and we will up here at the very top, we're going to say debug dot
Well, fine. I'm pretty sure this is not how I have done it before.
code. There's only one bracket there, sorry. So if we go into our world now, and we will up here at the very top, we're going to say debug.log generating new world using seed, and then we'll put in our voxel data dot seed. So if we run that, and I'll take maximize off so we can see the console, switch over to the console. If we run that now, we get a null reference exception because I haven't dragged the title into the, I haven't dragged the object across. So if I click on a title menu, we have this seed field now. So we need the seed. We haven't actually named the seed panel. So let's do that.
Fuck.
World seed. And then we want to drag in the seed text object into this seed field. So if we get the text, not the text area or the input field, but the text, and drop that in there. Now if we press play, we should not have any errors. I'm going to set that to, I don't know why that's just decided to zoom in by itself. Unity has been very weird today. And we click start game, saying generating new world using seed whatever 256047. It's generating the hash code. However, you can see that the world is a bit weird, and this is something that I found that happens when you put very large values into the Perlin noise generator, and I haven't really done any research yet to figure out why. Let's just close that and I'll show you how I can fix it. Now the first thing is that using get hash code, there is a possibility you can get a minus number, and we don't want a minus number because one thing that is definite is that when Perlin noise goes from negative to positive numbers, you get basically a complete break. Like it's like two separate Perlin noises. So we only ever want to be positive numbers, and given that everything that we generate starts from whatever number we start from and goes upwards, then that means that as long as our number is not negative, we should never cross that boundary, because we're never going backwards, we're never going down in numbers, we're always going up. We start at 0 and we go forwards, or we go right. We never go minus to the left or minus to the back. So we make sure it's a positive number by saying mathf.abs. And then to keep the number down, what I've done is to just divide it by voxel data.world size in chunks. So we'll try it again, and this time we'll use a different seed. Click start game. And now things are starting to look a bit more normal again.
All right, let's see. Again, I did something, and now I'm paying the price. I set this to be integer number, but if we set it to standard again, the letters there we go. Runs like absolute dog shit right now. No, it's done.
Again. If we cancel that and one last time, we'll use a different seed. And there we go. So that's the seed part. Now we need to get our settings done. So the first thing we want to do now is we want to go into our world script, we want to go down to our settings, and we need to give this lot a default set of values, because we can't guarantee that there will be a settings file. As you found out if you tried to build the game, it doesn't carry over all the external files, all the files that aren't part of the assets. It doesn't carry those files over. So if there is no settings file there, we need to create one, and if we're going to create one, we need to know what values to put in it. So I'm just going to set these to basically the same as what I've got them set currently. It doesn't matter if they're not exact. View distance, I believe, was 8. Enable threading is true. Enable animated chunks is false. And mouse sensitivity is... What is mouse sensitivity? Mouse sensitivity is 2. So that means that when we create a new instance of settings, it will have these values until we tell it otherwise. So now let's go into our title menu, and we're going to create a wake function. And then in here, we're going to...
Let's see. Enable threading. So you are in title menu. This episode was so boring.
I'm going to say if file doesn't exist, so if not file exists, application.data path plus, and then it's settings.cfg else. What have I done wrong here? Spell application wrong. That's what I've done. Very complicated word application. So in here, debug.log, no settings file found, creating new one. And then we need to be able to create a new one, and to do that we need to have some settings. So let's just go up here, settings, and then under here we're going to say settings equals new settings, and then that will create a new settings class with the values that we just assigned here, because we're not telling it anything different. And then we're going to say string JSON export equals JSON utility dot to JSON settings, and then we want to write that to file, so file dot write all text, and we'll just copy this, and then what we are writing is the JSON export. So that's what happens if there's no settings file. And if you can remember, this file.writeAllText, it will create a new file if no file exists, and it will overwrite an existing file if it's already there. So we don't need to worry about creating a file separately or saving over another one. This will just blast it out regardless of the situation. And then else debug.log settings file found, loading settings. And then for this one, actually, we'll just, if we go into world, we can just steal it from in here. So if we just quickly run that to test it, settings file found, loading settings. And then if we rename our settings file just for testing purposes, so now it's not going to find that settings file. No settings file found, creating new one. And then if we go back in here, sometimes you have to alt tab out to get it to show up. We have a new settings file, and it's got all the values that we set as default. So now we need to make our settings menu work. So let's just, for the time being, close that down and open this up. I want to go back into our title menu, and we need to bring in a shed load of new assets references. So this is the settings menu. And then under here, we need a public slider, which we'll call view dist slider. Public text mesh pro UU view dist text. Then another slider for mouse, which I'm just going to call slider. You can rename these however you like. Text mesh pro UU mouse text slider. And then finally, two toggles, toggle threading toggle, and public toggle chunk anim toggle. Again, if you didn't do the chunk animation loading thing, you don't need to worry about that. So let's just, before I forget, because I always do, go and add these references. So in our title menu, we now have all these settings menu elements. View distance slider, mouse slider. Which one's which? Oh, we only did one toggle. So let's just firstly rename that threading. Threading toggle, and then duplicate that, drag it up above the done button, and this one chunk anim toggle, and then we want to rename this. Where's the text? There's the text. Chunk animations, we'll just call it. So then back to our title menu, and we want to drag in our toggle for threading, and then our toggle for animations. And then finally we need the text, which is the view distance O and mouse sensitivity O, which is there. So that's the view distance one, and then in the mouse slider there. Right, so that's all the references we need. So what we want to do is we want to go into here, and we want to slide down to our enter settings, and we're going to type a load of stuff out. So view distance slider dot value equals settings dot view distance. View distance text dot text equals, and then we're going to say view distance plus settings dot view distance. Do you know, actually, we're not going to use settings dot view distance. We're going to use view distance slider value, because then it's definitely the view distance that is on screen. And then same again for mouse slider. And then for the toggles, all we're going to say is threading toggle dot is on equals settings dot enable threading, and chunk anim toggle dot is on equals settings dot enable animated chunks. So let's just, now bearing in mind this only gets called when we enter the settings menu, so this won't work if we start the game in the settings menu. So let's re-enable main menu, disable the settings menu. No, that's just the header. There we are. Now if we press play, click on settings, the toggles work, the mouse sensitivity. Oh, I think I know what's happened. Firstly, we need to go into our, where is it? Into our view distance slider, and we need to tell this to use only whole numbers, because our view
Whole numbers.
distance is in whole numbers. We can't have 1.5 view distance. It has to be 1, 2, etc. And then the max value, you can set this to whatever you want. I'm going to go between 4 and 32. And then for the mouse slider, we don't want whole numbers. However, we do want to limit it. So I'm going to say minimum value 0.5, maximum value 3.5. Let's try that again. There we go. That's much better. Now, as you can see, the text is not updating, and that's because we are only telling it the value once. And also, when we click done and go back into settings, it's reset because we're not saving those. So let's fix those two things. So back in here, we're going to drop down to the bottom here, and we're going to add in two new script functions. Public voids have to be public because we're going to be accessing them from outside. And we're going to say update dist slider, or update view dist slider. Doesn't need to take in any parameters. And then a public void update, not update, mouse slider. And then all we're going to do in here is steal this. And then for the mouse one, steal that. And then instead up here, we're just going to call those two functions. And then if we go back into our inspector and we find, where are we? Mouse slider, you can see we have an event window here, only this time instead of on click, it's on value changed. So this gets called anytime we change a value. So let's add an event, drag in our title menu. And which one are we looking at here? We're looking at the mouse slider. So go down, title menu, update mouse slider. And then for the same again for the view distance, add an event, drag in the title menu, update view distance slider. So let's just test that. There we go. Working view distance.
And breathe.
And working mouse. Now, as you can see, it's doing like 158 decimal places. So let's just quickly fix that. And we do that by going down to here, and we're just going to say mouse slider value dot to string, and then we're going to pass in F1. And what that does is going to limit it to 1 decimal place. If you put F2, it would be 2 decimal places, F3, 3 decimal places, etc. So now let's try that. There we go. 1 decimal place, much neater. And again, the min-max values change as you wish. Mess with the settings, you know, make it look how you want it to look. So finally, we want to make it so it saves. In leave set.
What I want to do is done should be at the bottom there.
Settings. Where is that? There. We need to set all those values back to the settings class. So settings dot view distance equals, and we need to recast this as an int because it is by default a float, even though we're telling it to use whole numbers. View distance slider dot value settings dot mouse sensitivity equals mouse slider dot value. That one is a float, so that's fine to leave as it is. And then settings dot enable threading equals threading toggle dot is on, and settings dot enable animated chunks equals chunk anim toggle dot is on. So now when we leave the settings, it does actually set our settings to the correct values that we've just changed it. So if I change the view distance to 30, click done, and then go back
I'm
in,
trying to
it's
finish
still on
off all my
30.
sugar
So
today.
the only thing that's left to do now is to actually write those back to the file, which we do by copying. If we go into world, it's commented out here, but this was how we did that before. So let's just copy that, get rid of the debug.log. So now if we look at our, we can just delete this renamed settings. If we look at our settings file, it's got view distance 8, enable threading true, animated chunks false, etc. Let's click play. We'll set all the values different to what they were. So enable threading false, chunk animations true, mouse sensitivity 1.5, view distance 21. Click done. And now if we open settings, all of those settings have been saved. I'll just drop this view distance to some.
That. It's 0.
Something ridiculously small, click done and start the game. And now we have a tiny little world. A tiny little world that is being loaded very slowly because threading is turned off, but is animated as it loads. And you can see you have this little debug.log telling us that it found the settings file correctly and it generated the new world using that seed. And that is that. So I hope you liked this video. The only thing left for me to do now is to thank my amazing subscribers and my even more amazing Patreons, and especially Professor DJ, who is at the sugar daddy / mama level and is a super supporter. So I hope you enjoyed this video. Thank you again to everyone who watches. Please like and subscribe if you haven't.
We'll do one more video because this one is also long, 44 minutes.
Hello and welcome to video 22. Of the how to make a game like Minecraft in Unity. Unity series, and in this video we are going to be tackling fast clouds. So I was going to try and do the whole cloud system in one video, but then the whole reason that I'm doing the cloud video now rather than the cross-trunk lighting video is because the cross-trunk lighting video is going to be a bit of a monster, and I didn't think I had time to do a stupidly long video, because as long as the video itself is to watch, it's so much longer to make. So I thought I'd do the cloud one instead, which ended up being at least 5 times longer than I thought it would, and that's just to do the fast clouds part. So let's get straight into it. The first thing we're going to do is we're going to run the game and just change these settings, because we left them on some random settings before. We want enable threading, and we don't want animations, and I'm going to leave the view distance quite low because we don't have to wait for the world to load up every time we're testing it. And then just click done, and that has saved our settings. And then we're going to go into our scenes folder, and we're going to rename this main here, because we've got main menu, that's this one. We're going to rename this to world, or you can call it game or something, just something descriptive. And then we're going to open that because we don't want to be going through the menu every time we want to test out what we're doing. So if we go into our scripts and we find our voxel data script and open that up, we're just going to add a little value that will come in handy later in this video. I'll just stick it here, and it's just going to be to get the center of the world. So but remember, the center of the world will change depending on the world size. And we'll just do that by returning world size in chunks.
He spelled it center,
times chunk width.
R-E. Fuck you.
And then we're dividing that by 2. And that's as simple as that. And seeing as we've created this, we may as well go into our world script and use it in this point down. Is it spawn position? Yeah, I think spawn position, where we create the spawn position. There's no point in doing all this here when we've got a value ready for it. So we just replace all
One
this.
more time. Alright, we have to go back. Fuck you, bro.
And then we're dividing that by 2. And that's
Yeah. I bought Valheim? Alright.
as simple as that. And seeing as
It's
we've
pretty
created
neat.
this, we may as well go into our world script and use it in this point
Pretty
down.
basic, but
is it spawn position?
Pretty
Yeah,
neat.
think
I
spawn
really like
position.
playing it once. Where are you, world?
Where we create the spawn position is no point in doing all this here when we've got a value ready for it. So we just replace all this with voxel data dot world center.
Do that?
If we go back into Unity and go into our textures folder, we can see that I have brought in this texture here. Now, we could do this with noise, with purling noise. However, that's not the way Minecraft does it, as far as I can tell. And also, that would mean going over some stuff that we've already done. And as much as possible, I'm trying to do things, you know, without making it unnecessarily complicated or difficult. I'm trying to do things in different ways so that we're not just repeating ourselves, so that we're doing something a bit different every time. So we're going to use the same way that I think Minecraft do it, which is to use a repeatable tiled texture to determine when the clouds are. So this is one that I found on the internet. I couldn't find anyone to credit with this one. I think it might be from the actual game though, which would explain why. But yeah, so this is just a bog standard noise texture, and we just need to do a bit of setting up. So first off, we need to tell it that alpha is transparent. We need to enable read write, and we may as well set this to 512 because the size of the image is 512. But also it's important to note that if your texture is not a multiple of 2, the way that we're going to do it will not work. So it has to be 32 by 32, 64 by 64, 256 by 256, 4096 by 4096, whatever it is, it has to be a multiple of 2, or a power of 2, I think it is, sorry. Or the way that we're going to do it will not work. So apply all that, and then let's go into our scripts and create a cloud script. I'm
Cloud?
just going to call it clouds. Let's open that up. So the first thing we're going to create is a public int, which we're going to call cloud height. I'm going to set it to 115. Obviously in Minecraft it's different. I think it started out, it was 2 blocks above the maximum, so it should be 100, what we got, 120, it should be like 130 or something. But then the size of the chunks was extended to 256, and that made the clouds just above halfway in the total build height. We haven't done the double height build height yet, so we're still on 128 high chunks. So we're just going to put this at 115 so that it is with, well actually we'll make it a bit lower. We'll put it at 100 so that it is within the build height. And we're going to create a reference for the aforementioned texture, which we will make private because we don't need to get it anywhere else. Texture 2D, and we're just going to call it cloud pattern. And we don't need to, but it's better if we set it to null, because whenever you set something as serialized field and you don't give it a value, it says that it comes up with a warning. This value is never assigned. So if we set it to null, it just stops it throwing up those annoying warnings. We're going to create a bool array, a 2-dimensional array, and this is going to work very similar to the voxel map in our chunk scripts. And we're going to call it cloud data. Now, as you will probably recognize from many of my other videos, we're going to need some lists to store our mesh information. So a list of vertices, which are vector 3s. A list of ints, which are triangles, or a list of triangles, which are ints. And we're going to give ourselves a list of normals, which are also vector 3s. We don't need any UVs for this one because we're not going to be texturing our clouds, we're just going to be giving them a solid color. And also we need an int to keep track of how many vertices we have put into our lists. We need a start function. And in our start function, we're going to say transform.position equals new vector 3, and we're going to get our voxel data dot world center. We're going to put it at cloud height, and obviously voxel data dot world center again. Mesh filter, which we're just going to call MF for now, is going to equal get component mesh filter. And then just so we don't forget, we'll go back into Unity now. We will create a cloud object.
Please go back.
Mesh filter. And then just so we don't forget, we'll go back into Unity now. We will create a cloud object.
And now we are inside world.
Create empty. We'll call it clouds, and we're going to add our cloud script there. And let's drag these values in before we forget. So our cloud texture there, and we want to add a mesh renderer, because you can't see it without a renderer, and a mesh filter, which is what we need to modify. So now we're not going to forget to do that. Now we need to create a mesh to put on that mesh filter. So first off, we're going to say private void void load cloud data. We don't need to take in any values for this, and this is going to populate this array. Before we do that, actually, we're just going to create another int, which we're going to call cloud text width. So that's just the width of the cloud texture, and then we'll set that in here.
The lights keep flickering all the time. I don't know.
Cloud text width equals,
are we under attack?
Cloud pattern dot width. So cloud data equals new bool, and we'll just say cloud text width by cloud text width. Now we're going to need an array of colors for our texture. Now we could just use getPixel on the texture. There's a function called getPixel where you give it the coordinates of a pixel and it returns that pixel, or it returns a color representing that pixel. We could just use that. However, that is quite slow compared to using get pixels, which returns an array of colors, and then we can manipulate that array. So that way works out quite a bit quicker than if we just individually grab pixels from the texture directly. So first of all, let's initialize our array. So color, it's a one-dimensional array, which is a bit annoying, but that's the way they do it. We'll just call it cloud text, and it's going to equal cloud pattern dot get pixels. So now we're going to loop through the color array and set all of our bools. We just copy that because I'm not sure how good this is going to look after editing, but my typing today is absolutely atrocious. So there will be as much copying and pasting as possible. So this is going to be looping through all of the positions in the texture. However, this is a one-dimensional array, so we can't simply use X and Y like we will be doing in this two-dimensional array. So the way we get around that is, first of all, we set it X and Y. And then we're going to say equals, because it's a bool, we need to give it a true or false value. We're going to get our true or false value by passing in a condition directly, rather than saying if this, then that, or whatever. We're just going to give it the condition directly, and we do that by putting a conditional statement in some brackets. So cloud text, I'm sorry if you can hear noise in the background, but there's a guinea pig in the room with me, and it seems to be going absolutely mental right now. Cloud text, and then we get the position by saying y times cloud text width. So that's getting us the up and down position on our texture. The cloud text width times the y value plus x, and then that gives us the position along. And then we want the alpha value, and we're going to say if that alpha value is greater than naught. Sorry, this should be cloud data. So what this is doing is, if this condition is true, it's setting it to true. If it's false, it's setting it to false. And all we're doing is looking at the opacity value of that particular color. So what we're saying is the opacity greater than 0? If it is, then there is cloud there, and if it isn't, there isn't cloud there. So next we need a function to get a mesh out of all this. So let's say mesh get cloud mesh. Again, we don't need to take any values for this, and we'll just once again copy this because Lord knows I can't type it. And we're going to be going to cloud text width once again, and this time what we're going to do is say if cloud data xy. So that's if that is true, because that's storing a bool, so it's a condition in and of itself. If it's true, then do this. And what we're going to do here is we're going to call a function that we haven't created yet. Just pass in the x and y value. And then at the end of the function, now this function, when we've written it, is going to automatically add to these lists. So once we've done that, we're going to say mesh equals new mesh mesh.vertices equals vertices.toArray. Mesh.triangles equals triangles.toArray. Mesh.normals equals normals.toArray, and then we're going to return mesh. So now to get rid of this error, we just need to create that function. So let's go down here and do that. I'm going to do another private void, add cloud mesh data. And this time we do need to take in some values. We need an int x and an int z, I'm going to call it. So add for vertices for cloud face. And we're just going to add a new vector3, and it's going to be x0 x z. Now these are local position values, so the global position, the position of where this actual piece of vertices will be in the world, or this piece of mesh will be in the world, will be determined by the object that it is on. However, this here is a local value to this game object, which is why we're not giving it a Y value, because we're already setting our Y value up here with the cloud height. So if we also put cloud height here, then the game object would be, what did we set it at, 100? The game object would be at 100, and then the mesh would be 100 above that. Now if we just copy these, because we need to add 4 of these to represent one cubic face, one square, one quad, whatever you want to call it. And then we're just going to go around. So we're going to go bottom left corner, top right corner, bottom right corner. So that is X and Z, and then X and Z plus 1, and then X plus 1 and Z plus 1, and then finally X plus 1. Now for the normals, we know what direction our
I think I kind of understand this now.
Facing, so we can just add them directly. And just because I don't want to type out 4 lines of code when I can type out 2, we're just going to say for int I equals 0, I is less than 4, I plus plus, normals dot add vector 3 dot down. Just remember the cloud, we're going to be looking up at the clouds. We'll handle looking down at the clouds in the fancy clouds video, because as far as I know, it's not an issue in fast clouds. I don't think you can see fast clouds from above. Could be wrong about that. Either way, we will be fixing it in the fancy clouds video. So there are 2 triangles to a quad, so let's add the first triangle. And we're going to do this the manual way, so triangles dot add vert count. Now this is sort of counterintuitive. We need to go backwards anti-clockwise, because we're going to be looking at these from underneath, so we want the bottom face, not the top face, to show up. So I've worked this out in advance, so trust me, this is the right way around. But this is basically drawing the triangles anti-clockwise. So we're starting off with the second one, that's this one, the, what would that be, the front left vertices, and then I'll just copy this. And then the next one is the bottom left vertices, and then the final one is the front right vertices. It's a bit difficult to visualize, really. It's a lot easier to think of it as up, down, left, right. And
I'm a little bit confused about this though. Add vert count. Why is he doing that?
And then we're going to add the second triangle. And the order this time is 2, 0, 3. And then we want to increment our vert count. And we just do that by saying plus equals 4, because we've added 4 vertices. Now if we go back up to our start function, we can say load cloud data, and then mf.mesh equals get cloud mesh. Now we can try this, and it's not going to work for a reason I will show you. So the first thing you'll notice is that it's purple, which for those of you who've played with Unity before in any depth will probably know why. We haven't given it a material to make it not purple, which we'll handle that. In fact, we'll just do it now straight away. So if we just go into our materials folder, create a new material, there we go.
Oh. So what is he doing? Hold on.
And then
Is the cloud still bugged? One too many there.
mf.mesh equals get cloud mesh. Now we can try this, and it's not going to work for a reason I will show you. So the first thing you'll notice is that it's purple, which for those of you who've played with Unity before in any depth will probably know why. We haven't given it a material to make it not purple, which we'll handle that. In fact, we'll just do it now straight away. So if we just go into our materials folder, create a new material, there we go. We'll call it clouds, and then we'll just make it unlit for now. Unlit color, and we'll set the color slightly off white. And then we can drag that onto our clouds component. There we go, at least the white now. However, we gave it a square texture, and that is not square. You don't need to be an expert in geometry to know that. That's a rectangle. So the reason for that is if we go into our clouds object here and we find our mesh, which is here, and we click on this, you can see there are 235,880 verts. Now Unity doesn't do that many verts, or at least it does. We could change the type of mesh to accommodate more verts. However, that's not really going to benefit us in the long run, because as you'll see later in the video, we really need our clouds to be broken up into smaller chunks anyway. So rather than increase the memory footprint of the mesh and make it allow more verts, we're going to break it up into smaller pieces. So firstly, let's go up to here, and we're going to need a public reference or a serialized field reference to our material. And again, we're going to set it to null so we don't get an annoying error or warning, and then we're immediately going to go in and drag it in so we don't forget to do it.
Right, let me see.
An annoying error or warning, and then we're immediately going to go in and drag it in so we don't forget to do it later, because that is something I do on a regular basis. So we'll just put that in there. We can get rid of this mesh renderer and mesh filter because we're not going to be using that anymore. What we are going to do is we're going to create a function to make a whole game object. So private game object create cloud tile. It's going to take in a mesh, and it's going to take in a position. So we're going to say game object new cloud tile equals new.
Strange there.
Game object, and then we're going to say new cloud tile dot transform dot position equals position. New cloud tile dot transform dot parent equals transform. So that just makes things nice and neat in the hierarchy. It's going to put it as a child of this clouds object. And then just so we can see what's going on in the hierarchy, we're going to give it a name as well. So new cloud tile dot name equals, and then we're going to say cloud space plus position dot x plus comma and a space in speech marks, just to make it neat. Position.z. Remember, we're not using the y position because they're all on the same level. And then finally, well, not finally, there's a few more lines yet. Mesh filter mf equals new cloud tile dot add component. And then mesh renderer mr equals new cloud tile dot add component mesh renderer. And then down here we can say mr dot material equals, and then we're just going to grab that cloud material, and then mf dot mesh equals mesh, the mesh that we're going to pass in, and then we can just return new cloud tile. So that creates a whole game object with mesh renderer and mesh filter from scratch. So we're going to need a couple of other values before we carry on. One of them we're going to call cloud tile size. So cloud tile size, and that is going to be the size of our individual cloud pieces that we're going to break our larger tile into. And then we're going to need a vector3 int, which we're going to call offset, and then we'll set those values. So cloud tile size, and this is why our texture needs to be a power of 2, because we're going to set our cloud tile size to the same size as our chunks. So voxel data dot chunk width. And the reason for that is because it makes it a bit easier to tie this into the check view distance or the player movement updates that we've already got in place. So later on when we have the clouds follow the player around, because obviously if there's just a 512 by 512 grid of clouds in the middle of the world and it just stays there, it's not going to be very good looking. So we need those clouds to follow the player around, but also they need to look like they're fixed in the world. So we can't just have the position of the clouds follow the player. We need to actually move the clouds while keeping the clouds in the same physical space. I'm making a mess of explaining this, but basically if we tie the width of the cloud tiles in with the width of the chunks, then that means that we can use the same update system. And then offset is going to be spelt right, is going to equal a new vector3 int, and we're going to say minus cloud data dot, no, we're not going to say cloud data dot get length because we have a value for that. So minus cloud text width 0 because we're not doing anything with the height, minus cloud text width. So we'll go back down to here. We're going to add another function. So now to start tearing up what we created in the earlier part of the video. So if we grab these, no, not that one, these 4 values here. Just rip them out. We're going to plonk them down in our, where is it? Here. And then we're going to enclose all of this in a for statement and a couple of if statements, or a couple of for statements and one if statement. So we'll say for int x increment equals 0. And the reason we're going to be keeping this x and z, so that's why we can't say just x. X increment is less than cloud tile size, x increment plus plus. And then we will copy that and do the same with Z. And if we just go down here and enclose those. This error we get in here is because we need to set this to 0. We need to give it a value before we can use it. And then the next thing we're going to do is we're going to create 2 values, which we're going to say int x val equals x plus x increment. And then same for Z. Zval equals z plus, don't know where that equals sign came from, z plus z increment. And then we're going to, the whole purpose of this is because what we're going to be doing now is this x and z value is going to be sort of the position of the cloud tile. So like the bottom left hand corner or the back left hand corner of the cloud tile. And then the x increment is going to be each position within the cloud tile map. I'm doing a really terrible job of explaining this. So if I'll just pull this picture up, it might make it a bit easier to explain. So we're breaking this up into chunks of 16. And what we're doing is x and z value represents the bottom left hand corner of each chunk. So this is a rather large chunk, but if we were looking at a chunk, then this down here would be the coordinate we're passing in. And then the x increment and the z increment represents each point within this chunk. So that's why we need this x val, because this x val gives us the actual position, which corresponds to, where is it, cloud data, which is what we use to check if there is a cloud at a given point. So I'm going to say if cloud data x val z val, and then once again wrap all this up in those curly brackets, and then we just need to change these because we need to use the x increment value, not the x value, because the x value is going to be the same for all of this, but the x increment value would change. Now we're going to change this to a mesh instead of a void, and we're going to change the name to create cloud mesh. And we're going to steal this code and plonk that in the bottom.
Steal what?
mesh. And we're going to steal this code and plonk that in the bottom here. Now if we turn our attention back up to this where we've got all these errors, and we're going to simply, well, first off we're going to just call it create clouds, because whatever we called it a second ago is no longer accurate. And we're going to make it a void because it's no longer returning a mesh. And we're going to delete this. Now we're going to say create cloud tile, and then to get the mesh we're going to say create cloud mesh, pass in our X and Y values. And then for our position, we're going to say new vector3 x0 z y, sorry, plus transform.position. So that offsets it by wherever we've put our cloud position, and then we're going to add that to our offset value. Now if we go up to our start, we don't need this mesh filter part anymore. And we don't need to directly set a mesh anymore. We need to carry on calling our load cloud data. That function hasn't changed, but now we call our create clouds function. If we run that, we should find we have an error. Oh, I know what I've done. So in this loop here, this should be plus equals cloud tile size, because we're not adding one every block, we're adding one every cloud tile. Let's just try running that again. There we go. Now we've got the full size 512 by 512 cloud texture tile map thing. However, it's starting at 0, and that is because
Let's blend. We've got some clouds over there, yeah. It looks like absolute dog shit.
this needs to be divided by 2 and enclosed in brackets.
Why? Oh, whatever. Well, I mean, I understand the offset, but
Oh, no, we finished fixing all those errors. Let's try that.
Brackets.
Okay, there we go. Right, we've got some clouds. So obviously, as I was saying before, there's no use to these clouds if they don't move with the player, because if I just grab our player here, and this is going to completely break the chunk loading algorithm because it's not designed to work this fast, but if I grab the player and just drag him over here, as you can see, the clouds are soon left behind. Our player's stuck in the ground. Yeah, so we've left our clouds behind. Oh, we're in a tree. So that's no good. So let's get that working. To do this, we're going to create a dictionary, which I think might be the first time I've used a dictionary in any of my videos. So our key is going to be vector2 int, and the type is going to be game object. So for those of you who haven't played with a dictionary before, basically this is like the index. So instead of giving a number to an index, we are using an object type, in this case a vector2 int. So what this means is we can use coordinates as the index to access the game object that we're going to be storing in this dictionary. We'll just call it clouds, and it's going to equal a new dictionary, and then you basically initialize them the same way that you do a regular list or queue. And then we're going to need a function for creating or converting a regular vector3 position, a global position, into something we can use with our dictionary. So let's just say private vector2 int cloud tile pos from v3. There's a nice mouthful of a name. And that's going to take in a vector3, which we'll just call pos. And then we're going to need another one, which is going to be a private int cloud tile chord from float. And that's going to take in a float value. And that's that. Now we'll start with this one because we're going to be this one we need in this one. So let's do this first. Random bracket there that we didn't need. So we start off float, and we're just going to call it A. It doesn't really matter what this one's called. And we're going to say value divided by, and then we need to cast it as a float, cloud text width. And this gets the position using cloud texture width as units. So what I mean by that is our cloud texture is 512 at the minute. So this gives us kind of a position, a coordinate, if 512 was one unit. So if it was 512, it would be 1. If it was 1024, it would be 2. If it was 4096 or whatever it is, it would be 4. And you get the idea. Then what we're going to do is say a minus equals mathf dot floor to int a. And then what that's doing is it's taking away any decimal places. So mathf.floor to int, if this returned a value of 2.467, this would equal 2. So saying a minus this would turn 2.467 into just 0.467. So that's what we're going to use it as. We're going to use the 0 to 1 value that we get from this to represent where we are in the actual cloud texture. And then finally we get int b equals mathf.floor to int. And then we need to cast this as a float. Cloud text width times a. So if a had ended up equaling 0.5 and the cloud text width is 512, then this will return 256, which is half of 512. So it gives us the position within the world relative to this tile map. But the good thing about this is it repeats, it wraps. So once you go past 512, it doesn't then start looking at 600 and something. It goes back to 0, and that's what we want. And then we're just going to return B. And then easily we can use this to get the value from here, which we're going to say vector2 int, new vector2 int, cloud tile chord from float, and we're going to pass in pos.x. There is no y because we're using a vector2 int, and if there was a y it would be 0, and then we want to set this to pos.z. That's that function done. So if we go to modify our quick...
What did you do? This should have had a large C.
So if we go to modify our create clouds function, and we're going to change this so that we have a vector3 position is going to equal a new vector3 x cloud height z, and we're going to change this to say clouds dot add cloud tile pos from vector3, pass in the position, and then the game object, we're going to get our create our cloud tile thing the same way we've done in the other function. Create cloud mesh xz position, only it's not Z, it's Y. So what this is going to become now is, that's also Y, this is a one-time function, and what this is going to do is it's going to run at the start and it's going to create all of our cloud objects. So I think 16 by 16, or is it 32 by 32? Yeah, 512 divided by 16. 32 by 32, which is like 10... That's 1024 cloud objects. So this is going to create all 1024 cloud objects and add them into this dictionary. And the idea is that once they're created, we don't need to create them anymore. We're just going to move them around. Like if you decide that you need your clouds to be further off into the distance than the 512 tile map allows, then you're going to have to mess with your code and change things. For this, I'm assuming that 512 is plenty for cloud view distance. So we're never going to need to duplicate any of these individual cloud tiles. We're always going to be able to just use the same ones, and when we need one at the other end, we can just take it from the far end rather than making another one. So if I run it now, it should work, but our clouds are going to be in the wrong place. Yeah, you see they're all off at 0, 0 because we're not offsetting them anymore, because we're going to be doing that using the player position. So to get out of that player position, we need a reference to our world. So serialize field, private world, and again we're going to equal null, and again we will go drag that in before we forget, and then we're going to come down here and underneath create clouds, because you can put it wherever you want. This is just where I'm putting it. We're going to create a public void called update clouds. And we will copy this because I don't want to type it out again. Now, first thing we do is we get a vector3 position, and it's going to equal world.player. No, sorry, player is a transform, so world.player.position plus new vector3 x0 z plus offset. And then we need to modify this position before we can use it, but to do that we're going to create a little function just to make things a little bit easier. So this is just going to be a private int, and we're going to call
I'm gonna regret that.
it round to cloud, and all this is going to do is it's like floor to int or whatever. It's going to take in a float value, and it's going to return an int value that is the cloud tile position that value is in. So if there was a cloud at, well, there's a cloud at 16 by 16, like 16x, 16z. If we gave it 17, it would return 16. If we gave it 23, it would return 16. If we gave it 33, it would return 32, and so on. So it's just going to take in a float value, and we're just going to return mathf dot floater int value divided by cloud tile size, and then times cloud tile size. Oh, have I missed a bracket off here? Oh, no, I haven't missed one off. I've added one that I didn't need. So we're getting the value divided by cloud tile size, and then we're rounding it down so that we get rid of any decimals, and then we're timesing it by cloud tile size to get back to where we were, but minus the decimal points. So now we can use that value by saying position equals new vector3 round to cloud, and we're just going to pass in position.x. This time we need to use cloud height because everything is going to be set relative to the player, and if we don't set cloud height here, it's going to be adjusted by the way the player, by the position of the player, and obviously the position of the player goes up and down, and we don't want that. Don't miss off that bracket. And then once again round to cloud position.z. So that's going to, I keep doing this, it's a Y, not a Z. So that's going to adjust our position so that it locks on to an absolute cloud tile position rather than sort of shuffling around depending on where the player is. And then
why are these Ys? I don't get it.
To int cloud position, and that's going to equal cloud tile pos from v3, and we're just going to pass in our position. And then we're going to say cloud position dot transform dot position equals position. And remember, because we've created all the clouds already, and because we're not planning on using more than the initial 512 by 512 grid of clouds, we don't need to worry about whether this exists. We know it exists because we created it. So if I just quickly, just for our demonstration's sake, I put that there and then press play, the clouds are still going to be in the wrong place. Now the reason for that is because we're using the player as our marker, and that is the position the player was at the time the clouds loaded, because the player's position doesn't get set immediately. The player's position, if I find our world script, gets set, where's generate world? Gets set here after we've generated our world. Well, the clouds are working much quicker than that. So if we go back into our clouds, delete that, we don't need that. We go into our world and we find some other references that it can group with. It looks fine. We're just going to create a public clouds, and then once again let's go and drag that in before we forget, so I don't get very confused by why we've got errors. And down here somewhere, there we go, clouds. So we just drag that clouds in, go back to our world script, and we want
That.
to find, where is it, player position, there, just under here. We're going to say clouds dot update clouds. Now if we run it, we should find the clouds moved to where the player is. There we go. However, that's not the end of it, because if I break my game again by grabbing the player and dragging him away, you can see the clouds still stay where they are. So we can easily fix that by just copying this line and putting it in, well, actually cutting this line, because we're not going to need it there, because as you can see, we immediately run check view distance after we've set the player's position, and all we're going to do is in check view distance, wherever I've put it, at the very top, we're going to call it there. So check view distance, if you remember, only runs once the player has moved from one chunk to another. So if the player sits still, this never gets called. So we call it once at the very start, and we're going to run this then, and then anytime the player moves from one chunk to another, we will call it again. So now, if I press play, you can see it's moved to where the player is, and if I grab hold of that player and drag him around, there we go, the clouds are moving with us. And eventually I'm going to run out of world here, but you get the idea. And that is an infinite and repeatable system. So those clouds are never going to, unlike the world, which has boundaries, the clouds are never going to run out or come up with an index out of range. So there is one last thing that we're going to do before I end this mammoth video, which hopefully will edit down into something a little more watchable than what I've recorded, is we're going to create a shader, because our clouds are solid and white, and obviously that's not how they look in Minecraft. So we're just going to create a little shader so we can make them transparent. So we'll go into our scripts, create a shader, and we're going to use an unlit shader. It doesn't really matter because we're going to delete all of it, and we're going to call it cloud shader, and we'll open that up. And this is a nice, this is nothing like all the other shaders I've done. This is a very short, brief thing. So shader Minecraft, and we'll call it cloud shader. Oh, sorry, that should be in speech marks. And then we want our properties, and we've only got one property, and that is color, which we'll just call color.
Oh my god, what is he doing? Look at this shit. This is such BS. Why would you do that? Fuck off. Piece of shit.
Type color, and that's going to equal 1 1 1 1 by default. 1 1 1 1 1 is white and fully opaque. This last one, if you don't remember, is the alpha, the opacity. So this is your RGB, red, green, blue, and then how transparent it is. So by default, it's solid white and completely opaque. And then we need our subshader. And in here, we want our tags, and our tags are Q equals, transparent, and ignore projector equals true, and render type equals transparent. And once again, that wants to be in speech marks. And we're going to say zwrite off. There's no semicolons here. Lighting off, because we don't want it to be affected by any of the Unity standard lighting because we're not using any of it. And we want fog. And for this one, you have to put in curly brackets and say mode off. I have not done enough research into shaders to know what all of this means, why all of this works the way it does. For example, this next line, I'm not 100% sure it does, but I know it's necessary. So we
I have done things with this.
Blend,
I know what this
source,
means.
Source alpha, 1 minus source alpha.
I have fucked around with this quite a bit.
Okay, and now we can put our pass in. The pass I do understand. And in our pass, all we have to write this time, unlike the other shaders that we messed around with, is color, and then in square brackets, pass in that color value. And that is, I think, all of it.
What do you mean all of it?
We'll soon find out if we get any errors.
What the fuck are you saying?
Material and clouds. Minecraft. Oh, I must have done something wrong because it's not letting me load it.
Yeah,
Oh, we do have an error. Unexpected. Line 7. What have I done wrong on line 7? Oh, that should be tags, not tag. There we go. Okay, so if we go into our cloud shader, go into Minecraft, we should, yep, there we go, clouds.
This works?
Then I'll run it so we can see it in action live. We'll look up at our clouds. We should be able to alter the transparency.
What the fuck?
There we go.
Why?
So make that as light or as dark as you want. I believe in Minecraft they sort of take on a bit of a blue tinge at nighttime, which is something we can now easily modify from within the script. But that's things like that I'll probably handle when I bring in time as an element. So like daytime, nighttime, that kind of thing. So for now, that's the end of this video. The only thing left to do is to thank my amazing Patreons, as always. And Professor DJ gets an extra special thanks for being an extra special supporter. But you are all very much appreciated, and I will be back very soon. I'm sorry this video was later than normal. My life is a bit of a hectic mess at the minute, including my house being a construction site. So yeah, I will get on it as soon as I can, and I'm thrilled to bits that you've all been so patient about this video. Thanks again, and I will see you next time. Bye-bye.
Should these still have been like this? Yeah. Okay, fine. Alright, but that's gonna be that for today. It's already late. I might stream tomorrow, but tomorrow is usually some day where some random person stops by or whatever. We'll see. I might just do some of these off stream tomorrow. Not that it really matters if I stream them or not. So that'll be that for today. Thanks for hanging. Have a good night. Bye bye.